Sound check, students. Quickly let me know in the chat right now if I am audible and visible to each and every one of you. Good evening, good evening, good evening, students. Welcome to Karnataka. Okay. Now, students, ಹೆಂಗಿದ್ದೀರಾ ಎಲ್ಲರೂ ಮಕ್ಕಳೇ? ಹೆಂಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? How is your preparation coming along? ಸ್ವಲ್ಪ ಜಾಕೆಟ್ ಹಾಕೊಂಡ್ಬಿಡ, ಸ್ವಲ್ಪ ಚಳಿ ಇದೆ ಯಾಕೆ ಗೊತ್ತಿಲ್ಲ. ರಾತ್ರಿ ಹೊತ್ತು ಶೆಕೆ ಇರುತ್ತೆ, ಬೆಳಗ್ಗೆ ಹೊತ್ತು ಸ್ವಲ್ಪ ಚಳಿ ಆಗೋಗುತ್ತೆ, ಯಾಕಂತ ಗೊತ್ತಿಲ್ಲ. ಓಕೆನಾ? Students, quickly tell me in the chat, how is everyone doing? ಹೆಂಗಿದ್ದೀರಾ ಎಲ್ಲರೂ? ಬೇಗ ಹೇಳಿ. How is the preparation coming along? How is the entire question practice ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಸಿಲೆಬಸ್ ನ ಓದ್ತಾ ಇದ್ದೀರಾ? ಫಿಸಿಕ್ಸ್ ಎಷ್ಟು ಮುಗ್ದಿದೆ ನಿಮ್ದು? ಕೆಮಿಸ್ಟ್ರಿ ಎಷ್ಟು ಮುಗ್ದಿದೆ? ಬಯಾಲಜಿ ಎಷ್ಟು ಮುಗ್ದಿದೆ? ಸ್ಟೂಡೆಂಟ್ಸ್ ಬೇಗ ಹೇಳ್ತೀರಾ ಎಲ್ಲರೂ ಕಮೆಂಟ್ ಅಲ್ಲಿ ಒಂದ್ಸತಿ? ಬೇಗ ಹೇಳಿ ಕಮೆಂಟ್ ಅಲ್ಲಿ ನಂಗೆ. ಹೌ ಇಸ್ ದ ಪ್ರಿಪರೇಷನ್ ಕಮಿಂಗ್ ಅಲಾಂಗ್ ಅಂತ ಇಲ್ಲಿ ಚಾಟ್ ಅಲ್ಲಿ ನೋಡ್ಬಿಡೋದ? ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಕಾಣಿಸ್ತಾ ಇದೆ. ಪರ್ಫೆಕ್ಟ್ ಸ್ಟೂಡೆಂಟ್, ಪರ್ಫೆಕ್ಟ್. ನಮಸ್ಕಾರ, ನಿಮಗೂ ನಮಸ್ಕಾರ, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಸರಿನಾ? ಓಕೆ. ಹೆಂಗೆ ನಿಮ್ಮದು ಸ್ಟೂಡೆಂಟ್ಸ್? ನಿಮ್ಗೆ ಒಂದ್ಸತಿ ನಿಮ್ಗೆ ಕೇಳೋದು ಮರ್ತೋಗ್ಬಿಟ್ಟೆ ಇದನ್ನ. ವಾಟ್ ಈಸ್ ಯುವರ್ ಏಮ್ ನಾವು? ಎಷ್ಟು ನಿಮ್ಮದು ಪರ್ಸೆಂಟೇಜ್ ಎಷ್ಟು ಏಮ್ ಮಾಡಿದ್ದೀರಾ? ನಿಮ್ಮದು ಎಲ್ಲರದು ಹೋಪ್ಫುಲಿ ನಿಮ್ಮೆಲ್ಲರದು ಏಮು ಅಟ್ಲೀಸ್ಟ್ 95% ಇದೆಯಾ ಎಲ್ಲರದು ಸ್ಟೂಡೆಂಟ್ಸ್? ಎಸ್. ಟುಮಾರೋ ಪ್ರಿಪ್ರೇಟರಿ ಬಯೋ. ಓಹ್, ಬೆಸ್ಟ್. ಇಲ್ಲ, ಸೌಜನ್ಯ ಕಳಿಸಿದ್ದಾರೆ, ಲಾಸ್ಟ್ ಫಸ್ಟ್ ಇದು ಕಳಿಸ್ಬಿಟ್ಟಿದ್ದಾರೆ ಆಗಲೇ. ನೆನ್ನೆ ಕ್ಲಾಸ್ದು ಕೂಡ ಕಂಪೈಲೇಷನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. 1 ಮಾರ್ಕ್ 2 ಮಾರ್ಕ್ ಆಗಲೇ ಕಳಿಸಿದ್ದಾರೆ. ಚೆಕ್ ಮಾಡಿ, ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಚೆಕ್ ಮಾಡಿ, ಆಗಲೇ ರೆಡಿ ಇದೆ. ನಾಳೆ ಪ್ರಿಪ್ರೇಟರಿ ಬಯೋನ ಸೈಕ್ ಚೆನ್ನಾಗಿರುತ್ತೆ, ಇವತ್ತು ಚೆನ್ನಾಗಿರುತ್ತೆ ಕ್ಲಾಸು. ಓಕೆನಾ? ಯಾಕಂತಂದ್ರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ನಿಮಗೆ ಈ ಹಾಟ್ಸ್ ಕ್ವಶನ್ ಗೊತ್ತಾ? ಹಾಟ್ಸ್ ಕ್ವಶನ್ ಒಂದು ಮಾಡಿಸ್ತೀನಿ ಇವತ್ತು. ನಿಮಗೆ ಫುಲ್ ಮಜಾ ಬಂದ್ಬಿಡುತ್ತೆ ಹಾಟ್ಸ್ ಕ್ವಶನ್ ಮಾಡಿ. ಓಕೆನಾ? ಸೊ ಬನ್ನಿ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ ಸ್ಟೂಡೆಂಟ್ಸ್, ಬನ್ನಿ ಸ್ಟಾರ್ಟ್ ಮಾಡುವ ಎಲ್ಲರೂ? ಓಕೆ ನೋಡಿ, ಇದು ಎಲ್ಲಾ ಕ್ವಶನ್ಸ್ ಇದೆಯಲ್ಲ ನಿಮ್ದು, ಈ ಎಲ್ಲಾ ಕ್ವಶನ್ಸ್ ನಿಮ್ದು 5 ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ ಫುಲ್. ನಿಮ್ದು ಸೆಕ್ಷುವಲ್ ರಿಪ್ರೊಡಕ್ಷನ್ ಆಫ್ ಫ್ಲವರಿಂಗ್ ಪ್ಲಾಂಟ್ಸ್ ಇಂದ ಈ ಎಲ್ಲಾ 5 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್ ಇದು. ಮೋಸ್ಟ್ ಆಸ್ಕ್ಡ್ 5 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಫ್ರಮ್ ಸೆಕ್ಷುವಲ್ ರಿಪ್ರೊಡಕ್ಷನ್ ಇನ್ ದ ಫ್ಲವರಿಂಗ್ ಪ್ಲಾಂಟ್. ಸರಿನಾ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಾವು ಇದನ್ನೆಲ್ಲ ಮುಂಚೆ ಮಾಡಿದೀವಿ 2 ಮಾರ್ಕಲ್ಲಿ 3 ಮಾರ್ಕಲ್ಲಿ. ಎಕ್ಸ್ಪ್ಲೇನ್ ದ ಟಿಎಸ್ ಆಫ್ ಮೆಚೂರ್ ಡಯಾಸಿಯಸ್ ಆಂಥರ್. ನೆನಪಿದ್ಯಾ? ನಾನಿಂದ ನಿಮ್ಗೆ 3 ಮಾರ್ಕಲ್ಲಿ ಹೇಳಿದ್ದೆ. ದಟ್ ಇಸ್ ಎಪಿಡರ್ಮಿಸ್, ಎಂಡೋಥೀಸಿಯಂ, ಮಿಡಲ್ ಲೇಯರ್, ಆಮೇಲೆ ಟಪೀಟಮ್. ಆ ಕ್ವಶನ್ ಇದು ಬರತ್ತಿದು. ಅದಾದ್ಮೇಲೆ ಅನಾಟ್ರೋಪಸ್ ಆರ್ ಮೆಗಾಸ್ಪೊರಾಂಚಿಯಂ ಬಗ್ಗೆ ಕೇಳ್ತಾರೆ. ಆಮೇಲೆ ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕು ಮತ್ತೆ ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅನಾಟ್ರೋಪಸ್ ಓವ್ಯೂಲ್ ಕೇಳ್ತಾರೆ. ಈ ಎರಡಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಬರುತ್ತೆ. ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕಲ್ಲಿ ನಿಮ್ಗೆ ಫುಲ್ ಡಯಾಗ್ರಾಮ್ ಇದೆಯಲ್ಲ, 3 ಸಿನರ್ಜಿಟ್ಸು, 1 ಎಕ್ಸೆಲ್. ನೋಡಿ ಇದು ಈ ಡಯಾಗ್ರಾಮ್ ಕೇಳ್ತಾರೆ. ನೋಡಿ ಇದು ಅನಾಟ್ರೋಪಸ್ ಓವ್ಯೂಲು, ಇದು ನಿಮ್ದು ಮೆಚೂರ್ ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕ್. ಈ 2 ಕ್ವೆಶನ್ ಅಲ್ಲಿ ಒಂದು ಬರುತ್ತೆ ಯಾವಾಗೂ. ಇದನ್ನ ನೀವು ಆಗ್ಲೇ ನಾವು 3 ಮಾರ್ಕಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಇಲ್ಲಿ ನಿಮ್ಗೆ ಸಿನರ್ಜಿಟ್ಸ್ ಏನಂದ್ರೆ ಏನು, ಎಗ್ ಅಪಾರಟಸ್ ಅಂದ್ರೆ ಏನು, ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಸರಿನಾ? ನೆಕ್ಸ್ಟ್ ನಿಮ್ಗೆ ಇವತ್ತು ಹಾಟ್ಸ್ ಕ್ವೆಶನ್ ತೋರಿಸ್ತೀನಿ, ಫುಲ್ ಮಜಾ ಬರುತ್ತೆ. ಓಕೆನಾ? ಟೈಪ್ಸ್ ಆಫ್ ಪಾಲಿನೇಷನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಆಟೋಗೆಮಿ, ಝೀನೋಗೆಮಿ ಮತ್ತೆ ಗೈಟನೋಗೆಮಿ, ಈ 3 ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಇಲ್ಲಿದ್ನ ಮೊನೊಕಾಟ್ ಎಂಬ್ರಿಯೋ, ಕೋಲಿಯೋಪ್ಟೈಲ್, ಕೋಲಿಯೋರೈಸಾ ಎಲ್ಲ ಫುಲ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಇದು ಸೀಡ್ ಅದು. ಎಂಬ್ರಿಯೋ ನಿಮ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ, ಹಾರ್ಟ್ ಶೇಪ್, ಗ್ಲೋಬ್ಯುಲರ್ ಶೇಪು. ಸ್ಟೂಡೆಂಟ್ಸ್, ಈಗ ನಿಮ್ಗೊಂದು ಕ್ವೆಶನ್ ತೋರಿಸ್ತೀನಿ ನೋಡಿ. ಎಷ್ಟು ಜನಕ್ಕೆ ಆ ಕ್ವೆಶನ್ ಅರ್ಥ ಆಗುತ್ತೆ, ಎಷ್ಟು ಜನಕ್ಕೆ ಆ ಕ್ವೆಶನ್ ಅರ್ಥ ಆಗಲ್ಲ ನಂಗೆ ಬೇಗ ಹೇಳಿ. ಇದು ಕ್ವೆಶನ್ ನಿಮ್ದು. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಹಾಟ್ಸ್. ಇದೆಲ್ಲ ಈಸಿ ಕ್ವೆಶನ್. ಮೆಗಾಸ್ಪೋರೋಜೆನೆಸಿಸ್, ಮೈಕ್ರೋಸ್ಪೋರೋ ಎಲ್ಲ ಈಸಿ ಕ್ವೆಶನ್ ಇದೆಲ್ಲ. ಡೈರೆಕ್ಟ್ ಆಗಿ ನೀವು NCERT ಓದಿದ್ರೆ ಈ ಎಲ್ಲ ಕ್ವೆಶನ್ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಈ ಕ್ವೆಶನ್ ನೋಡಿ, ಐ ವಿಲ್ ಗಿವ್ ಯು ಎಕ್ಸಾಕ್ಟ್ಲಿ 10 seconds ಟು ರೀಡ್ ದ ಕ್ವೆಶನ್ ಅಂಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕ್ವೆಶನ್. ಟ್ರೈ ಮಾಡಿ. ಸೈಕ್ ಕ್ವೆಶನ್ ಇದು. ಲೆಟ್ಸ್ ಸಿ ಹೌ ಮೆನಿ ಕ್ಯಾನ್ ಟ್ರೈ ದಿಸ್ ಕ್ವೆಶನ್. ಏನಪ್ಪಾ? ಡಬಲ್ ಫರ್ಟಿಲೈಸೇಷನ್ ಇಸ್ ಎ ಯೂನಿಕ್ ಫೀಚರ್ ಆಫ್ ಆಂಜಿಯೋಸ್ಪರ್ಮ್ಸ್. And the products of this double fertilization is zygote and PN. ಫಸ್ಟ್ ನೀವು ಡಬಲ್ ಫರ್ಟಿಲೈಸೇಷನ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ. ಸರಿನಾ? ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಇದು ನಿಮ್ದು ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕ್ ಅಂದ್ರೆ ಇದು ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕು. ಇಲ್ಲಿ 2 ಸಿನರ್ಜಿಡ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಒಂದು ಎಗ್ ಸೆಲ್ ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ದಿಸ್ ಇಸ್ ದ ಎಗ್ ಸೆಲ್. ಇಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ಏನಿರುತ್ತೆ? ಸೆಂಟ್ರಲ್ ಸೆಲ್ ಇರುತ್ತೆ ಇಲ್ಲಿ. ಓಕೆ, ಸೆಂಟ್ರಲ್ ಸೆಲ್ ಏನು ಡಿಪ್ಲಾಯ್ಡ್ ಆಗಿರುತ್ತೆ, ಎಗ್ ಹ್ಯಾಪ್ಲಾಯ್ಡ್ ಆಗಿರುತ್ತೆ. ಸರಿನಾ? ಇಲ್ಲಿ ಬಂದು ಪೋಲೆನ್ ಟ್ಯೂಬ್ ಇಲ್ಲಿ ಪೋಲೆನ್ ಟ್ಯೂಬ್ ಒಡೆ ಬರುತ್ತೆ ಥ್ರೂ ಸಿನರ್ಜಿಟ್ಸ್. ಇಲ್ಲಿ ಪೋಲೆನ್ ಟ್ಯೂಬ್ ಬರ್ಸ್ಟ್ ಆದ್ರೆ ಇಟ್ ವಿಲ್ ರಿಲೀಸ್ 2 ಮೇಲ್ ಗ್ಯಾಮೆಟ್ಸ್, ಒಂದು ಮೇಲ್ ಗ್ಯಾಮೆಟು ಇನ್ನೊಂದು ಮೇಲ್ ಗ್ಯಾಮೆಟು, ಇದು ಎರಡು ಹ್ಯಾಪ್ಲಾಯ್ಡು, ಎರಡು ಹ್ಯಾಪ್ಲಾಯ್ಡು. ಇದರಲ್ಲಿ ಒಂದು ಮೇಲ್ ಗ್ಯಾಮೆಟು ಈ ಎಗ್ ಜೊತೆಗೆ ಹೋಗಿ ಫ್ಯೂಸ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಮೇಲ್ ಗ್ಯಾಮೆಟು ಇಲ್ಲಿ ಮೇಲೆ ಹೋಗಿ ಫ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸರಿನಾ? ಈಗ ನಂಗೆ ಹೇಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಈ ಎಗ್ ಪ್ಲಸ್ ಒನ್ ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ಈ ಫ್ಯೂಷನ್ ಆದ್ರೆ ವಾಟ್ ಇಸ್ ದ ರಿಸಲ್ಟ್? ಏನಾಗುತ್ತೆ? ಈ ಎಗ್ಗು ಒಂದು ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ಫ್ಯೂಸ್ ಆದ್ರೆ ಝೈಗೋಟ್ ಆಗುತ್ತೆ. ಅದು ಝೈಗೋಟ್. ಇದು ಏನಿದು? ಹ್ಯಾಪ್ಲಾಯ್ಡು, ಇದು ಕೂಡ ಹ್ಯಾಪ್ಲಾಯ್ಡು. ಸೊ n ಪ್ಲಸ್ n ಇಸ್ 2n. ಸೊ ಝೈಗೋಟ್ 2n ಆಗಿರುತ್ತೆ. ಈ ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ದಟ್ ಇಸ್ ಸೆಂಟ್ರಲ್ ಸೆಲ್ ಪ್ಲಸ್ ಏನಪ್ಪ ಒನ್ ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ಫ್ಯೂಸ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ? ಈ ಫ್ಯೂಸ್ ಆದ್ರೆ ಎಂಡೋಸ್ಪರ್ಮ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಇದು ಸೆಂಟ್ರಲ್ ಸೆಲ್ ಏನು? ಸೆಂಟ್ರಲ್ ಸೆಲ್ ಇಸ್ ಡಿಪ್ಲಾಯ್ಡ್, ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ಇಸ್ ಹ್ಯಾಪ್ಲಾಯ್ಡ್, 2n ಪ್ಲಸ್ n ಏನು? 3n. ಇದು 3n ಆಗಿರುತ್ತೆ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಸಿನ್ಗ್ಯಾಮಿ. ಇದನ್ನ ಟ್ರಿಪಲ್ ಫ್ಯೂಷನ್ ಅಂತಾರೆ. ಯಾಕೆ ಟ್ರಿಪಲ್? ಈ ಸೆಂಟ್ರಲ್ ಸೆಲ್ ಅಲ್ಲಿ ಎರಡು ನ್ಯೂಕ್ಲಿಯೈ ಇದೆ. ಸೊ ಎರಡು ನ್ಯೂಕ್ಲಿಯೈ, ಇಲ್ಲೊಂದು ನ್ಯೂಕ್ಲಿಯೈ, 3 ನ್ಯೂಕ್ಲಿಯೈ. ಇದು ಟ್ರಿಪಲ್ ಫ್ಯೂಷನ್ ಸಿನ್ಗ್ಯಾಮಿ. ಎರಡು ಸೇರಿಸಿ ಏನಂತ ಕರೀತಾರೆ? ಎರಡು ಸೇರಿಸಿ ಡಬಲ್ ಫರ್ಟಿಲೈಸೇಷನ್ ಅಂತ ಕರೀತಾರೆ. ಸರಿನಾ? ಇದು ನಿಮ್ಗೆ ಗೊತ್ತು, ಎಲ್ಲರಿಗೂ ಗೊತ್ತು ಡಬಲ್ ಫರ್ಟಿಲೈಸೇಷನ್. ಬಟ್ ಈ ಕ್ವೆಶನ್ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಏನ್ ಕ್ವೆಶನ್ ಇದು? ಇನ್ ಅ ಕಾಂಟೆಕ್ಸ್ಟ್ ಆಫ್ ದಿಸ್, ವೆನ್ ಅ ಹೆಕ್ಸಾಪ್ಲಾಯ್ಡ್ ಪ್ಲಾಂಟ್, ಹೆಕ್ಸಾಪ್ಲಾಯ್ಡ್ ಅಂದ್ರೆ ಏನು? ಹೆಕ್ಸಾಪ್ಲಾಯ್ಡ್ ಅಂದ್ರೆ R6n. When a hexaploid plant is pollinated by tetraploid plant. Pollinated tetraploid, male tetraploid, female hexaploid. ಯಾಕೆ? is pollinated by, ಇದು ಇದಕ್ಕೆ ಪಾಲಿನೇಟೆಡ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಮೇಲ್. Tetraploid. Find out the ploidy of zygote and PN through schematic illustration. ಸೈಕಲ ಕ್ವೆಶನ್, ಸೈಕಲ. ಈಗ ಆನ್ಸರ್ ನೋಡಿ ನೀವು ಶಾಕ್ ಆಗ್ಬಿಡ್ತೀರಾ. ಸರಿನಾ? ಈಗ ಅಕಸ್ಮಾತ್ ಇದು ಟೆಟ್ರಾಪ್ಲಾಯ್ಡು, ಇದು ಹೆಕ್ಸಾಪ್ಲಾಯ್ಡ್ ಪ್ಲಾಂಟು. ಇಟ್ ಹ್ಯಾಸ್ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಸ್ಪೋರ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಮಿಯೋಸಿಸ್ ಆಗುತ್ತೆ, ಇಲ್ಲೂ ಕೂಡ ಮಿಯೋಸಿಸ್ ಆಗುತ್ತೆ. ಏನಾಗುತ್ತೆ? ಮಿಯೋಸಿಸ್ ಅಂದ್ರೆ ಏನು? ಕ್ರೋಮೋಸೋಮ್ ನಂಬರ್ ಹಾಫ್ ಆಗೋಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 4n ಅಂದ್ರೆ ಈ ಮೈಕ್ರೋಸ್ಪೋರ್ ಇದೆಯಲ್ಲ 2n ಇರುತ್ತೆ ಮೈಕ್ರೋಸ್ಪೋರ್. ಸರಿನಾ? 2n ಇರುತ್ತೆ. ಈಗ ಅರ್ಥ ಮಾಡ್ಕೋ, ಇದರಲ್ಲಿ ಮೆಗಾಸ್ಪೋರ್ ಏನಿರುತ್ತೆ? ಮೆಗಾಸ್ಪೋರ್ ಕೂಡ 3n ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 3n, ಇಲ್ಲಿ 2n. ಯಾಕೆ 3n? ಇದು 6n ಇದೆಯಲ್ಲ, ಮಿಯೋಸಿಸ್ ಆದ್ರೆ ರಿಡಕ್ಷನ್ ಡಿವಿಷನ್, ಅವಾಗ ಇದು 3n ಆಗೋಗುತ್ತೆ. 3n. ಸೊ 6n 3n ಆಗೋಯ್ತು. ಈಗ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಏನು? ನಾರ್ಮಲ್ ಸಿನ್ಗ್ಯಾಮ್ಲಿ ಏನಾಗುತ್ತೆ? ಒನ್ ಗ್ಯಾಮೆಟ್ ಎಗ್ ಝೈಗೋಟು, ಒನ್ ಮೇಲ್ ಗ್ಯಾಮೆಟ್ 2 ಪೋಲರ್ ನ್ಯೂಕ್ಲಿಯೈ PN. ಈಗ ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಒಂದು ಕ್ವೆಶನ್. ಈಗ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ಸಿನ್ಗ್ಯಾಮ್ಲಿ ಏನಾಗುತ್ತೆ? ಈ ಒನ್ ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ಎಷ್ಟು ಪ್ಲಾಯ್ಡ್? ಈಗ ಬೇಗ ಹೇಳಿ. ಈ ಮೇಲ್ ಗ್ಯಾಮೆಟ್ ಪ್ಲಾಯ್ಡ್ ಎಷ್ಟು? ಈಗ ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಎಲ್ಲೋ ಇಲ್ಲಿ 2n, ಇಲ್ಲೇನು 2n. ಸೊ 2n ಪ್ಲಸ್ ಎಗ್ ಯೂಶಲಿ n ಆಗಿರುತ್ತೆ. ಬಟ್ ಇಲ್ಲೇನಾಗಿದೆ ಎಗ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ಎಗ್ ಏನಿರುತ್ತೆ? 3n ಇರುತ್ತೆ. ಎಗ್ 3n ಇರುತ್ತೆ. ಬಿಕಾಸ್ ಮೈಕ್ರೋಸ್ಪೋರ್ ಇಸ್ 3n, ಇದು ಕೂಡ 3n ಇರುತ್ತೆ. ಈಗ ಸರಿನಾ? ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಇದು n ಇರುತ್ತೆ, ಇದು ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಕೂಡ ಇದು n ಇರುತ್ತೆ ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ. ಬಟ್ ಈಗ ಹೆಕ್ಸಾಪ್ಲಾಯ್ಡ್ ಟೆಟ್ರಾಪ್ಲಾಯ್ಡ್, ಸೊ ಇದೇನಾಗುತ್ತೆ? ಇದು 2n ಪ್ಲಸ್ 3n. ಬೇಗ ಹೇಳಿ ನಂಗೆ, ವಾಟ್ ಇಸ್ ದ ಪ್ಲಾಯ್ಡಿ ಆಫ್ ಝೈಗೋಟ್ ನಾವು? ಬೇಗ ಹೇಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಬೇಗ ಹೇಳ್ರಿ ಆನ್ಸರ್, ಬೇಗ ಹೇಳ್ರಿ. 3 + 2 ಮಾಡಿ ಬೇಗ. ದಟ್ ಇಸ್ 5n. ಇಲ್ಲಿ ಝೈಗೋಟು 5n ಆಗಿರುತ್ತೆ. ಈಗ ಟ್ರಿಪಲ್ ಫ್ಯೂಷನ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಇದು ನಾರ್ಮಲ್ 2n ಮೇಲ್ ಗ್ಯಾಮೆಟ್, ಸರಿನಾ? ಪ್ಲಸ್ ಒಂದು ಪೋಲಾರ್ ನ್ಯೂಕ್ಲಿಯೈ ಇಸ್ n. ಒನ್ ಪೋಲಾರ್ ನ್ಯೂಕ್ಲಿಯೈ, ಈ ಪೋಲಾರ್ ನ್ಯೂಕ್ಲಿಯೈ ಇದೆಯಲ್ಲ, 2 ಪೋಲಾರ್ ನ್ಯೂಕ್ಲಿಯೈ ಅಲ್ಲಿ ಇಲ್ಲಿ n ಪ್ಲಸ್ n ಆಗಿರುತ್ತೆ. ಇದು n ಪ್ಲಸ್ n ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ ಏನಾಗಬೇಕು? ಇಲ್ಲಿ 3n ಪ್ಲಸ್ 3n ಆಗಬೇಕು. ಇಲ್ಲಿ n ಪ್ಲಸ್ n ಇತ್ತು, ಅದಕ್ಕೆ 2n ಬಂತು. ಈಗ ಇಲ್ಲಿ 3n ಪ್ಲಸ್ 3n, ಯಾಕಂದ್ರೆ ಒನ್ ಎಂಟೈರ್ ಎವ್ರಿ ಸೆಲ್ ಇನ್ ಮೆಗಾಸ್ಪೋರ್, ಎವ್ರಿ ಸಿಂಗಲ್ ಸೆಲ್ ಇಸ್ 3n. ಇಲ್ಲಿ So this is 3n plus 3n, 6n. Tell me what is the answer now? Tell me what is the answer here? ಬೇಗ ಹೇಳಿ, ಆನ್ಸರ್ ಹೇಳಿ ನಂಗೀಗ. 6, 7, 8 ಟ್ರಿಪಲ್ ಫ್ಯೂಷನ್ 8, 10 ಆಗಿರುತ್ತೆ. ಈ ಕ್ವೆಶನ್ನ ನೀವು ಫಸ್ಟ್ ಟೈಮ್ ಮಾಡಿದ್ರೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗೇ ಆಗುತ್ತೆ. ಈ ಚಾಪ್ಟರ್ ಮುಗಿಸಾದ್ಮೇಲೆ, ಇವತ್ತಿನ ಸೆಷನ್ ಆದಮೇಲೆ ಕುತ್ಕೊಂಡು ಇನ್ನೊಂದ್ಸತಿ ಈ ಕ್ವೆಶನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಡೌಟ್ ಬಂದರೆ ನನಗೆ ಕಮೆಂಟಲ್ಲಿ ತಿಳಿಸಿ. ಐ ವಿಲ್ ಟೀಚ್ ಯು ಅಗೇನ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ದ ಓನ್ಲಿ ಥಿಂಗ್ ಇಸ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿಟ್ ಅಂಡ್ ಲರ್ನ್ ಆನ್ ಯುವರ್ ಓನ್ ದಿಸ್ ಒನ್ ಮೋರ್ ಟೈಮ್. ಈ ತರ ಸೈಕ್ ಕ್ವೆಶನ್ ನಿಮ್ಗೆ ಕೊಟ್ರೆ ಸಾಲ್ವ್ ಮಾಡಕ್ ಬರ್ಬೇಕು ನಿಮ್ಗೆ ಅಷ್ಟೇ, ಸರಿನಾ? ಅದ್ ಬಿಟ್ಟು ಏನ್ ಕ್ವೆಶನ್ ಕೇಳ್ತಾರಪ್ಪ, ಹೌ ಡು ಕರ್ನಲ್ ಅಂಡ್ ಕೋಕೋನಟ್ ವಾಟರ್ ಡಿಫರ್? ಇದ ಕೇಳ್ಬೋದು. ಇನ್ ಕೇಸ್ ಆಫ್ ಪಾಲಿ ಎಂಬ್ರಿಯೋನಿ, ಇಫ್ ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ಸ್ ಫ್ರಮ್ ದ ಸಿನರ್ಜಿಡ್ ಅಂಡ್ ಅನದರ್ ಫ್ರಮ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್, ದೆನ್ ವಿಚ್ ಇಸ್ ಹ್ಯಾಪ್ಲಾಯ್ಡ್, ವಿಚ್ ಇಸ್ ಡಿಪ್ಲಾಯ್ಡ್? ಇದೆಲ್ಲ ಹಾಟ್ಸ್ ಕ್ವೆಶನ್ ಅಂತಾರೆ, ಹಾಟ್ಸ್ ಕ್ವೆಶನ್ ಇದೆಲ್ಲ. ಓಕೆ, ಹೌ ವಾಸ್ ಇಟ್ ಪಾಸಿಬಲ್ ಇನ್ ಪ್ಲಾಂಟ್ಸ್ ಲೈಕ್ ಆಕ್ಸಾಲಿಸ್ ಅಂಡ್ ವಯೋಲಾ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಅಶ್ಯೂರ್ಡ್ ಸೆಟ್ ಆಫ್ ಸೀಡ್ಸ್? ಒನ್ ಬೈ ಒನ್ ಮಾಡದ ಬನ್ನಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಕೋಕೋನಟ್ ನೀವೆಲ್ಲ ಕುಡಿದಿರ್ತೀರ, ಎಳ್ನೀರಲ್ಲಿ ನೀವು ತಿನ್ನೋ ಪಾರ್ಟ್ ಇದೆಯಲ್ಲ, ಅದನ್ನ ನಾವು ಎಂಡೋಸ್ಪರ್ಮ್ ಅಂತ ಕರಿತೀವಿ. ಎಂಡೋಸ್ಪರ್ಮ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ. ಕೋಕೋನಟ್ ವಾಟರ್ ಇದೆಯಲ್ಲ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಫ್ರೀ ನ್ಯೂಕ್ಲಿಯರ್ ಲಿಕ್ವಿಡ್ ಎಂಡೋಸ್ಪರ್ಮ್. ಅದೇ ಕೊಬ್ಬರಿ ತಿಂತೀವಲ್ಲ, ಕೊಬ್ಬರಿ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಯುವರ್ ಮಲ್ಟಿಸೆಲ್ಯುಲರ್ ಸಾಲಿಡ್ ಎಂಡೋಸ್ಪರ್ಮ್ ಆರ್ ಸೆಲ್ಯುಲಾರ್ ಎಂಡೋಸ್ಪರ್ಮ್. ಇದು ಫ್ರೀ ನ್ಯೂಕ್ಲಿಯರ್, ಇದು ಸೆಲ್ಯುಲರ್ ಎಂಡೋಸ್ಪರ್ಮ್ ನೀವು ತಿನ್ನೋದು, ಸರಿನಾ? ಡಯಾಗ್ರಾಮ್ ಆಯ್ತಿದ್ದು. ಬೋತ್ ಕರ್ನಲ್ ಅಂಡ್ ವಾಟರ್ ಆಫ್ ಕೋಕೋನಟ್ ವಾಟರ್ ಕನ್ಸಿಸ್ಟ್ ದ ಎಂಡೋಸ್ಪರ್ಮ್. ಕರ್ನಲ್ ಇಸ್ ಸೆಲ್ಯುಲರ್ ಎಂಡೋಸ್ಪರ್ಮ್, ಕೋಕೋನಟ್ ವಾಟರ್ ಇಸ್ ಫ್ರೀ ನ್ಯೂಕ್ಲಿಯರ್ ಎಂಡೋಸ್ಪರ್ಮ್. ಈ ತರ ಬರದೆ ಮಾರ್ಕ್ಸ್ ನಿಮ್ಗೆ ಪಕ್ಕ ಸಿಗುತ್ತೆ. ಓಕೆ, ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್ ಏನಿತ್ತಪ್ಪ ಇಲ್ಲಿ? ಇನ್ ಕೇಸ್ ಆಫ್ ಪಾಲಿಎಂಬ್ರಿಯೋನಿ, ಇಫ್ ಅ ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ಸ್ ಫ್ರಮ್ ಸಿನರ್ಜಿಡ್, ಒಂದು ಎಂಬ್ರಿಯೋ ಸಿನರ್ಜಿಂದ ಡೆವಲಪ್ ಆಗ್ತಾ ಇದೆ. ಓಕೆ, ಅಂಡ್ ಅನದರ್ ಫ್ರಮ್ ನ್ಯೂಸೆಲಸ್, ವಿಚ್ ಇಸ್ ಹ್ಯಾಪ್ಲಾಯ್ಡ್, ವಿಚ್ ಇಸ್ ಡಿಪ್ಲಾಯ್ಡ್. ನೀವು ಫಸ್ಟ್ ನಿಮ್ಗೆ ಹೇಳ್ಬೇಕು ನನಗೆ, ಸಿನರ್ಜಿಡ್ ವಾಟ್ ಇಸ್ ದ ಪ್ಲಾಯ್ಡಿ? ಕೊಡೋದ PDF ಕೊಡೋದ, ಸಂಜು ಕ್ರಿಯೇಷನ್ಸ್ ಕೊಡೋದ, ಚಿಂತೆ ಮಾಡಬೇಡಿ. ಸರಿನಾ? ಸಿನರ್ಜಿಡ್ ಪ್ಲಾಯ್ಡಿ ಏನು? ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೆಲ್ಲಲ್ಲಿ, ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ, ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕ್ ಅಲ್ಲಿ ಈ ಸಿನರ್ಜಿಡ್ ಏನು? ಹ್ಯಾಪ್ಲಾಯ್ಡ್. ಇದು ಹ್ಯಾಪ್ಲಾಯ್ಡ್. ಎಗ್ ಏನು? ಎಗ್ಗು ಹ್ಯಾಪ್ಲಾಯ್ಡ್. ಆಂಟಿಪೋಡಲ್ ಏನು? ಹ್ಯಾಪ್ಲಾಯ್ಡ್. ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಪೋಲಾರ್ ನ್ಯೂಕ್ಲಿಯರ್ ಎಷ್ಟು? 2 ಪೋಲಾರ್ ನ್ಯೂಕ್ಲಿಯರ್ ಸೇರಿ 2n ಇರುತ್ತೆ. ನಾವು ಅಕಸ್ಮಾತ್ ಈ ಸಿನರ್ಜಿಡ್ ಇಂದ ಒಂದು ಎಂಬ್ರಿಯೋ ಬಂದ್ರೆ, ಸಿನರ್ಜಿಡ್ ಇಂದ ಒಂದು ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ ಆದ್ರೆ ಅದು ಹ್ಯಾಪ್ಲಾಯ್ಡ್ ಇರುತ್ತೆ, ಡಿಪ್ಲಾಯ್ಡ್ ಇರುತ್ತೆ? ನೀವ್ ಹೇಳಿ ಬೇಗ. ಹ್ಯಾಪ್ಲಾಯ್ಡ್ ಇರುತ್ತೆ. ಅದು ಸಿನರ್ಜಿಡ್ ಇಂದ ಬಂದ್ರೆ ಹ್ಯಾಪ್ಲಾಯ್ಡ್ ಇರುತ್ತೆ. ನೀವು ಅದೇ ಯೋಚನೆ ಮಾಡಿ. ಇಲ್ಲಿ ನೋಡಿ, ಈ ನ್ಯೂಸೆಲಸ್ ಇಲ್ಲಿದೆಯಲ್ಲ, ಇದು ನ್ಯೂಸೆಲಸ್ ಇಸ್ ಡಿಪ್ಲಾಯ್ಡ್ ಇನ್ ನೇಚರ್. ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು, ಅದು ನ್ಯೂಸೆಲಸ್ ಇಸ್ ಡಿಪ್ಲಾಯ್ಡ್. ಅಕಸ್ಮಾತ್ ಈ ಡಿಪ್ಲಾಯ್ಡ್ ನ್ಯೂಸೆಲಸ್ ಇಂದ ಒಂದು ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ ಆದ್ರೆ, ಮಣಿಕಂಠ ಹೇಳಪ್ಪ, ಏನ್ ಹೇಳು? ಇದು ನ್ಯೂಸೆಲಸ್ 2n. ಸೊ ಇಲ್ಲಿಂದ ಒಂದು ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ ಆದ್ರೆ ವಾಟ್ ವಿಲ್ ಬಿ ದ ಪ್ಲಾಯ್ಡಿ? ಟೆಲ್ ಮಿ. ಅದು ಕೂಡ 2n ಇರುತ್ತೆ. ಇಲ್ಲಿಂದ ಡೆವಲಪ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ? ಅದು n ಇರುತ್ತೆ. ಸೊ ಅಕಸ್ಮಾತ್ ಸಿನರ್ಜಿಡ್ ಇಂದ ಡೆವಲಪ್ ಆದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾಪ್ಲಾಯ್ಡ್. ನ್ಯೂಸೆಲಸ್ ಡೆವಲಪ್ ಆದ್ರೆ ಇಟ್ ಇಸ್ ಗೋನ್ ಟು ಬಿ ಡಿಪ್ಲಾಯ್ಡ್ ಇನ್ ನೇಚರ್. ಓಕೆ, ಒಂದು ಅಬ್ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ ಅನ್ಕೊಳ್ಳಿ. ಒಂದು ಅಬ್ನಾರ್ಮಲ್ ಕಂಡೀಷನ್, ಅಕಸ್ಮಾತ್ ಬೈ ಎನಿ ಚಾನ್ಸ್ ಈ ಆಂಟಿಪೋಡಲ್ ಇಂದ ಒಂದು ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ ಆಯ್ತು ಅನ್ಕೊಳ್ಳಿ. ಈ ಆಂಟಿಪೋಡಲ್ ಸೆಲ್ಸ್ ಇಂದ ಒಂದು ಎಂಬ್ರಿಯೋ ಡೆವಲಪ್ ಆಯ್ತು. ಅದು ಹ್ಯಾಪ್ಲಾಯ್ಡ್ ಇರುತ್ತಾ, ಡಿಪ್ಲಾಯ್ಡ್ ಇರುತ್ತಾ? ವಿಲ್ ಇಟ್ ಬಿ ಹ್ಯಾಪ್ಲಾಯ್ಡ್, ಡಿಪ್ಲಾಯ್ಡ್? ಟೆಲ್ ಮಿ, ಬೇಗ ಹೇಳಿ. ಆಂಟಿಪೋಡಲ್ ಇಸ್ ಹ್ಯಾಪ್ಲಾಯ್ಡ್, ಸೊ ಎಂಬ್ರಿಯೋ ಆಲ್ಸೋ ವಿಲ್ ಬಿ ಹ್ಯಾಪ್ಲಾಯ್ಡ್. ಸೊ ಆ ತರ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬರುತ್ತಾ? ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಹೌ ಮಚ್ ಯು ಪ್ರಿಪೇರ್. ನಾವು ಹೇಳೋದನ್ನ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀವಿ, ಸರಿನಾ? ಇದಾದ್ಮೇಲೆ ಈ ವೀಕಿಂದಾನೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲ ನೆಕ್ಸ್ಟ್ ವೀಕಿಂದಾನೆ ನಿಮ್ಗೆ ಎಲ್ಲಾ ಚಾಪ್ಟರ್ನ ಇನ್ನೊಂದ್ಸತಿ ಹೇಳ್ಕೊಡ್ತಾ ಇದೀವಿ ಲೈವ್ ಅಲ್ಲಿ, ರೆಕಾರ್ಡ್ ಫಾರ್ಮೆಟ್ ಅಲ್ಲಿ. ನಿಮ್ದು ಎಂಟೈರ್ ಬಯಾಲಜಿನ 1 ಅವರ್ ಅಲ್ಲಿ ಮಾಡ್ತೀವಿ. ಎವ್ರಿ ಸಿಂಗಲ್ ಚಾಪ್ಟರ್ನ 1 ಅವರ್ ಇಲ್ಲ 2 ಅವರ್ ಅಲ್ಲಿ ಮಾಡಿ ನಿಮ್ಗೆ ಕೊಡ್ತಾ ಇರ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ವೀಕಿಂದ ಬರುತ್ತದು, ಸರಿನಾ? ರೆಡಿ ಇರಿ, ಸರಿನಾ? ಮತ್ತೆ ವಿಯೋಲಾ ಮತ್ತೆ ಆಕ್ಸಾಲಿಸ್ ಅಲ್ಲಿ ಪಾಲಿನೇಷನ್ ಹೆಂಗಾಗುತ್ತೆ? ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಇದು ನಿಮ್ದು ಫ್ಲವರ್, ಇಲ್ಲಿ ನಿಮ್ದು ಫೀಮೇಲ್ ಫ್ಲವರ್ ಇಲ್ಲಿ ಮೇಲೆ ಇದೆ, ಮೇಲ್ ಫ್ಲವರ್ ಇಲ್ಲಿ ಕೆಳಗಡೆ ಇದೆ, ಮೇಲ್ ಫ್ಲವರು. ಸೊ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ವಿಯೋಲಾ ಮತ್ತೆ ಆಕ್ಸಾಲಿಸ್ ಅಲ್ಲಿ ವಿಯೋಲಾ ಮತ್ತೆ ಆಕ್ಸಾಲಿಸ್ ಅಲ್ಲಿ ಮೇಲ್ ಫ್ಲವರ್ ಇದೆಯಲ್ಲ, ಮೇಲ್ ಫ್ಲವರು ಇಲ್ಲಿದೆ ಅನ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿಂದ ಮೇಲ್ ಫ್ಲವರು ಫ್ಲೋಟ್ ಆಗಿ ಮೇಲೆ ಹೋಗುತ್ತೆ. ಮೇಲ್ ಫ್ಲವರು ಫ್ಲೋಟ್ ಆಗಿ ಮೇಲೆ ಹೋಗುತ್ತೆ ಅಂಡ್ ಇವೆಂಚುಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಟಾಪ್ ರೀಚ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಫೀಮೇಲ್ ಫ್ಲವರ್ ಮೇಲಿನ ಇರುತ್ತೆ, ಆಮೇಲೆ ಈ ತರ ಪಾಲಿನೇಷನ್ ಆಗುತ್ತೆ. ನೋಡಿ ನಿಮ್ಗೆ NCERT ಕೂಡ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. ಇದು ಎಂಟೈರ್ ಫೀಮೇಲ್ ಫ್ಲವರು, ಇದು ಮೇಲ್ ಫ್ಲವರು. ಮೇಲ್ ಫ್ಲವರ್ ಫ್ಲೋಟ್ ಆಗಿ ಮೇಲೆ ಹೋಗುತ್ತೆ, ಆಮೇಲೆ ಫರ್ಟಿಲೈಸೇಷನ್ ಆಗುತ್ತೆ. ಅದ್ರದ್ದು ಇನ್ಫಾರ್ಮೇಶನ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀವಿ ನೋಡಿ. ಇದನ್ನ ಓದ್ಕೊಳ್ಳಿ ಒಂದ್ಸತಿ. ವ್ಯಾಲಸಿನೇರಿಯಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸಿ ಗ್ರಾಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ. ವ್ಯಾಲಸಿನೇರಿಯಾ ಫೀಮೇಲ್ ಫ್ಲವರ್ ರೀಚಸ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ದ ವಾಟರ್ ಬೈ ಲಾಂಗ್ ಸ್ಟಾಕ್ and male flower or pollen grains are released on the surface of water. They are carried passively by water current and some of them eventually reach the female flower and stigma. So float ಆಗಿ ಮೇಲೆ ಹೋಗುತ್ತೆ, ಆಮೇಲೆ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಪಾಲಿನೇಷನ್ ಆಗುತ್ತೆ. ಇದು ಝಾಸ್ಟೆರಾ ಮತ್ತೆ ವ್ಯಾಲಸಿನೇರಿಯಲ್ಲೂ ಕೂಡ. ಸರಿನಾ? ನೋಡಿ ಹ್ಯೂಮನ್ ರಿಪ್ರೊಡಕ್ಷನ್ ಏನ್ ಕೇಳ್ತಾರೆ ನಿಮ್ಗೆ. ಹ್ಯೂಮನ್ ರಿಪ್ರೊಡಕ್ಷನ್ ಇಂದ ನಿಮ್ದು ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲೂ ಕೂಡ ಮುಂಚೆ ಕೇಳಿದಾರೆ ಈ ತರ. ಏನಪ್ಪಾ ಅದು, ಕಂಪ್ಲೀಟ್ ಡಯಾಗ್ರಾಮ್ ಕೇಳ್ತಾರೆ. ಇಟ್ ಕುಡ್ ಬಿ ಫೀಮೇಲ್ ರಿಪ್ರೊಡಕ್ಟಿವ್ ಆರ್ಗನ್, ಇಲ್ಲಾಂದ್ರೆ ಮೇಲ್ ರಿಪ್ರೊಡಕ್ಟಿವ್ ಆರ್ಗನ್. ಇದನ್ನ ಡ್ರಾ ಮಾಡಕ್ ಹೇಳ್ತಾರೆ. ಸೊ ನೀವು ಒಂದ್ಸತಿ ಕ್ಲಾಸಲ್ಲಿ ಇಲ್ಲ ಮನೆಯಲ್ಲಿ ಕುತ್ಕೊಂಡು, ರಜಾ ತಾನೆ, ಮನೇಲಿ ಕುತ್ಕೊಂಡು ಡಯಾಗ್ರಾಮ್ನ ಬಿಡಿಸಿ ಒಂದ್ಸತಿ. ಸರಿನಾ? ಬಿಡಿಸಾದ್ಮೇಲೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ. ಇಲ್ಲಿಗ ನೀವು ಲೇಬಲಿಂಗ್ ಮಾಡಾದ್ಮೇಲೆ ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ಎಕ್ಸ್ಟ್ರಾ ಕ್ವೆಶನ್. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ನೀವೆಲ್ಲ ಹೇಳಿ ಇಲ್ಲಿ ಈ ಕ್ವೆಶನ್ ನಿಮ್ದು ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 3 ಸತಿ ರಿಪೀಟ್ ಆಗಿದೆ. ಈ ಕ್ವೆಶನ್ ಆಲ್ಮೋಸ್ಟ್ 1 2 3 4 5 6 ಟೈಮ್ಸ್ ರಿಪೀಟ್ ಆಗಿದೆ. ಇದು 6 ಟೈಮ್ಸ್ 3 ಟೈಮ್ಸ್. ನಾವು ಇಲ್ಲೊಂದು ಕ್ವೆಶನ್ ಕೇಳ್ತೀನಿ, ಕೇಳಿಸ್ಕೊಳ್ಳಿ ನೀವೀಗ. ಟೆಲ್ ಮಿ ದ ಗ್ಲ್ಯಾಂಡ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಹಿಯರ್. ಟೆಲ್ ಮಿ ದ ಗ್ಲ್ಯಾಂಡ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಮೇಲ್ ರಿಪ್ರೊಡಕ್ಟಿವ್ ಆರ್ಗನ್. ಬೇಗ ಹೇಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್. ನೇಮ್ ದ ಗ್ಲ್ಯಾಂಡ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಮೇಲ್ ರಿಪ್ರೊಡಕ್ಟಿವ್ ಆರ್ಗನ್. ಯಾವ ಗ್ಲ್ಯಾಂಡ್ ಇದೆ ಇಲ್ಲಿ ಬೇಗ ಹೇಳಿ ನನಗೆ. ಸಮೈನಲ್ ವೆಸಿಕಲ್, ಪ್ರೋಸ್ಟೇಟ್, ಬಲ್ಬವಿರೋಧಲ್. ಈ 3 ಗ್ಲ್ಯಾಂಡ್ನ ನೀವು ಹೈಲೈಟ್ ಮಾಡಿ ಬರಿಬೇಕು. ಅದಾದ್ಮೇಲೆ ನಿಮ್ಗೆ ಕೇಳ್ಬೋದು ವಾಟ್ ಆರ್ ದ ಫಂಕ್ಷನ್ಸ್, ಏನ್ ಫಂಕ್ಷನ್ ಇದರದು ಅದು ಕೂಡ ಕೇಳಿದ್ರೆ ಬರಿಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ದು ಸಮೈನಲ್ ವೆಸಿಕಲ್, ಪ್ರೋಸ್ಟೇಟ್, ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಎನ್ಸೈಮ್ಸ್, ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಫ್ರಕ್ಟೋಸ್ ಮತ್ತೆ ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಕ್ಯಾಲ್ಸಿಯಂ. ಅದೇ ಬಲ್ಬವಿರೋಧಲ್ ಗ್ಲ್ಯಾಂಡ್ ವಿಲ್ ಪ್ರೊಡ್ಯೂಸ್ mucus or it provides a lubricant during copulation. ಈ ತರ ಬರೆದ್ರೆ ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ. ಸರಿನಾ? ಎಕಾಲಜಿನ ಮಣಿಕಂಡ ಡೋಂಟ್ ವರಿ, ಎಕಾಲಜಿ ನಾವು ಸಪ್ರೇಟ್ ಆಗಿ ವಿಡಿಯೋ ಮಾಡೋದ. ನಿಮ್ಗೆ ಪೂರ್ತಿ ಎಕಾಲಜಿನ ನಾನು ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ಮಾಡ್ಕೊಡ್ತೀನಿ. ಹೆಂಗೆ ಈ ವಾರ ನೆಕ್ಸ್ಟ್ ವಾರದಲ್ಲಿ ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ವೀಕಲ್ಲಿ ಬರುತ್ತೆ. ನೀವು ಆ ವಿಡಿಯೋ ಒಂದ್ಸತಿ ನೋಡ್ಕೊಳ್ಳಿ, ಫುಲ್ ಎಕಾಲಜಿನ ಫುಲ್ ಮುಗಿಸ್ಕೊಂಬಿಡಿ ಒಂದಸ್ತಿಗೆ. ಸರಿನಾ? ಆಮೇಲೆ ಇದು ನಿಮ್ ಫೀಮೇಲ್. ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಕೇಳ್ತಾರೆ, ವಾಟ್ ಆರ್ ದ 3 ಲೇಯರ್ಸ್ ಆಫ್ ಯೂಟ್ರಸ್. ಬೇಗ ಆನ್ಸರ್ ಹೇಳಿ ನಂಗೆ. ವಾಟ್ ಆರ್ ದ 3 ಡಿಫರೆಂಟ್ ಲೇಯರ್ಸ್ ಇನ್ ದ ಯೂಟ್ರಸ್ ಫೌಂಡ್. ಆನ್ಸರ್ ಹೇಳಿ ಬೇಗ ಹೇಳಿ ಆನ್ಸರು. ಬೇಗ ಹೇಳಿ 3 ಡಿಫರೆಂಟ್ ಲೇಯರ್ಸ್ ಫೌಂಡ್ ಇನ್ ಯೂಟ್ರಸ್. ಯೂಟ್ರಸ್ದು 3 ಲೇಯರ್ ಯಾವುದು? ಇಲ್ಲಿ ನಿಮ್ದು ಇನ್ನರ್ ಮೋಸ್ಟ್ ಲೇಯರ್ ಎಂಡೋಮೆಟ್ರಿಯಂ, ಮಿಡಲ್ ಲೇಯರ್ ಮಯೋಮೆಟ್ರಿಯಂ, ಔಟರ್ ಮೋಸ್ಟ್ ಲೇಯರ್ ಪೆರಿಮೆಟ್ರಿಯಂ. ಈ 3 ಲೇಯರ್ನ ಮಾರ್ಕ್ ಮಾಡಿ ಅದ್ರ ಬಗ್ಗೆ ಒಂದ್ ಲೈನ್ ಬರೀಬೇಕು ಅಷ್ಟೇ. ಸರಿನಾ? ಬಿಟ್ರೆ ಏನ್ ಕೇಳ, ಇದು ಬಿಟ್ರೆ ಇಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಇದು ಆಸ್ಕ್ ಯು ದಿಸ್ ಡಯಾಗ್ರಾಮ್ ಕೇಳ್ಬಿಟ್ಟು ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ವಾಟ್ ಇಸ್ ದಟ್, ನೇಮ್ ದ ರೀಜನ್ ವೇರ್ ಫರ್ಟಿಲೈಸೇಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಇಲ್ಲಿ ಫರ್ಟಿಲೈಸೇಷನ್ ಎಲ್ಲ ಆಗುತ್ತೆ ಅಂತ ಕೇಳ್ತಾರೆ ನಿಮ್ಗೆ. ಸರಿನಾ ಸರ್? ಎಲ್ಲ ಸಬ್ಜೆಕ್ಟ್ಗೂ ಬರುತ್ತೆ ಸಪ್ರೇಟ್ ವಿಡಿಯೋ. ಎಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿ ಮತ್ತೆ ಸರ್ ಫಿಸಿಕ್ಸ್ ಬರುತ್ತೆ, ಮ್ಯಾಥ್ಸ್ ಮತ್ತೆ ಕೆಮಿಸ್ಟ್ರಿ ಮ್ಯಾಮ್ ಕೇಳದ, ಬಯೋ ಕಡೆಯಿಂದ ಬಂದೇ ಬರುತ್ತೆ, ಬಯೋಯಿಂದ ಚಿಂತೆ ಮಾಡಬೇಡಿ. ಎವ್ರಿ ಸಿಂಗಲ್ ಸಬ್ಜೆಕ್ಟ್, ಎವ್ರಿ ಸಿಂಗಲ್ ಚಾಪ್ಟರ್ ಒಂದು ವಿಡಿಯೋ ಬರುತ್ತೆ ನಿಮಗೆ. ಇಲ್ಲ ಆಕ್ಚುಲಿ 2 ವಿಡಿಯೋ ಮಾಡೋದ. ಎವ್ರಿ ಸಿಂಗಲ್ ಚಾಪ್ಟರ್ಗೆ 2 ವಿಡಿಯೋ ಬರುತ್ತೆ, ಒಂದು ಥಿಯರಿ, ಒಂದು ಕ್ವೆಶನ್ಸ್ ನೆಕ್ಸ್ಟ್ ವೀಕಲ್ಲಿ. ಯಾಕಂದ್ರೆ ನೀವು ಎಲ್ಲರೂ ಒಳ್ಳೆ ರೆಸ್ಪಾನ್ಸ್ ಮಾಡಿದ್ದೀರಲ್ಲ, ಟು ಮೇಕ್ ಶೋರ್ ದ ರೆಸ್ಪಾನ್ಸ್ ಚೆನ್ನಾಗಿ ಬರಲಿ ಅಂತ ವಿ ಹ್ಯಾವ್ ಡಿಸೈಡೆಡ್ ದಿಸ್. ಓಕೆನಾ? ಸೊ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಕೇಳ್ತಾರೆ ದ ರೀಜನ್ ಆಫ್ ಫರ್ಟಿಲೈಸೇಷನ್ ಇಸ್ ಆಂಪ್ಯುಲಾ ರೀಜನ್ ಅಂತ ಬರೀಬೇಕು ನೀವು, ಆಂಪ್ಯುಲಾ. ಸರಿನಾ? ನೋಡಿ ಇದು ರಿಪೀಟೆಡ್ ಕ್ವೆಶನ್. ಇದು ಎಕ್ಸಾಮ್ ಪೇಪರ್ ಇಂದ ತಗೊಂಡಿದ್ದೀನಿ ಕ್ವಶನ್ಸ್ನ. ವಾಟ್ ಇಸ್ ದ ಪ್ಲಾಯ್ಡಿ ಆಫ್ ಸೆಕೆಂಡರಿ ಸ್ಪರ್ಮಸ್ ಕೇಳ್ಬೋದು. that is haploid. Sarna, helps in nutrition. Mention the axillary ducts of male. No, ducts. Read testis, vas efferentia, epididymis, vas difference. Yella ducts galo. They can ask you the difference between spermiation, spermatogenesis, semen, menopause or menarche. Ella kottiddivi illi. Sarna. Idu biಟ್ಟು they can ask you difference between spermatogenesis, oogenesis. ಈ ಕ್ವೆಶನ್ ಕೇಳ್ತಾರೆ ಸರ್ನಾ. ದಿ ಮೋಸ್ಟ್ ರಿಪೀಟೆಡ್ ಕ್ವೆಶನ್ ಇದು, ದಿ ಮೋಸ್ಟ್ ರಿಪೀಟೆಡ್ ಕ್ವೆಶನ್ ನಿಮ್ದು ಇದು ಕೂಡ. ಡಿಫ್ರೆನ್ಸ್ ಏನು ಬರುತ್ತೆ ಅಂತ ಸರ್ನಾ. ಸೊ ಈ ಪಿ ಡಿ ಎಫ್ ನಾನು ಇವತ್ತೇ ಕಳಿಸ್ತೀನಿ. ಆ್ಯಕ್ಚುಲಿ ನಿಮಗೆ ಲಿಂಕ್ಗೋಸ್ಕರ ವೆಯ್ಟ್ ಮಾಡಬೇಡಿ, ಇವತ್ತು ಟೆಲಿಗ್ರಾಮಲ್ಲೇ ಕಳಿಸ್ತೀನಿ ಇವತ್ತಾಗುತ್ತೆ ಸರ್ನಾ. ಹಾಂ, ಎಕ್ಸ್ಪ್ಲೇನ್ ದ ಮೆಕ್ಯಾನಿಸಮ್ ಆಫ್ ಪಾರ್ಚುರೇಷನ್ ಆ್ಯಂಡ್ ಹೆಲ್ಪ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಫೀಟಲ್ ಎಜೆಕ್ಷನ್ ರಿಫ್ಲೆಕ್ಸ್. ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಇದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್, ಎಲ್ಲರೂ ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಸರ್ನಾ. ಓಕೆ, ಈ ಕ್ವೆಶನ್ ಕೇಳಿಸ್ಕೊಳ್ಳಿ, ನಾನು ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ, ಕರೆಕ್ಟಾಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಇದನ್ನ. 9 months ಆದಮೇಲೆ ಬೇಬಿ ಇಸ್ ರೆಡಿ ಟು ಕಮ್ ಔಟ್. ಆಫ್ಟರ್ 9 months ಬೇಬಿ ಇಸ್ ರೆಡಿ ಟು ಕಮ್ ಔಟ್. ಬಟ್ ಆ ಫಸ್ಟ್ ಸಿಗ್ನಲ್ ಇರುತ್ತಲ್ಲ, ಎಲ್ಲಿಂದ ಬರುತ್ತೆ ಫಸ್ಟ್ ಸಿಗ್ನಲ್? ದ ಫಸ್ಟ್ ಸಿಗ್ನಲ್ ಫಾರ್ ಇಜೆಕ್ಷನ್, ದ ಫಸ್ಟ್ ಸಿಗ್ನಲ್ ಫಾರ್ ಇಜೆಕ್ಷನ್, ಇಟ್ ಈಸ್ ಆಕ್ಚುಲಿ ಕಮಿಂಗ್ ಫ್ರಮ್ 2 places, ಬೇಬಿಯಿಂದ ಮತ್ತು ಪ್ಲಾಸೆಂಟಾಯಿಂದ. ಸೊ ದ ಬೇಬಿ ಆ್ಯಂಡ್ ದ ಫೀಟಸ್ ಆ್ಯಂಡ್ ದ ಪ್ಲಾಸೆಂಟಾ ಗಿವ್ಸ್ ಅ ಸಿಗ್ನಲ್. ಆ ಸಿಗ್ನಲ್ನ ಫೀಟಲ್ ಇಜೆಕ್ಷನ್ ರಿಫ್ಲೆಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಸಿಗ್ನಲ್ ಬಂದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಈ ಸಿಗ್ನಲ್ ಬಂದ ತಕ್ಷಣವೇ ಫ್ರಮ್ ದ ಪಿಟ್ಯುಟರಿ ಗ್ಲ್ಯಾಂಡ್ ಆಕ್ಸಿಟೋಸಿನ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. ಏನಾಗುತ್ತೆ? ಆಕ್ಸಿಟೋಸಿನ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. ಆಕ್ಸಿಟೋಸಿನ್ ರಿಲೀಸ್ ಆಗಿದ ತಕ್ಷಣವೇ there will be contraction in the uterus. ಯೂಟ್ರಸ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ. ಯೂಟ್ರಸ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಮತ್ತೆ ಆಕ್ಸಿಟೋಸಿನ್ ಹೋಗುತ್ತೆ, ಜಾಸ್ತಿ ರಿಲೀಸ್ ಮಾಡುತ್ತೆ. ಮತ್ತೆ ಆಕ್ಸಿಟೋಸಿನ್ ರಿಲೀಸ್ ತಕ್ಷಣ ಮೋರ್ ಕಾಂಟ್ರಾಕ್ಷನ್, ಮೋರ್ ಆಕ್ಸಿಟೋಸಿನ್, ಮೋರ್ ಕಾಂಟ್ರಾಕ್ಷನ್. ಆ ಥರ ಆಗ್ತಾ 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 ಫೈನಲಿ ದ ಗ್ಯಾಪ್ ಇಸ್ ವೈಡ್, ಬೇಬಿ ಇಸ್ ಔಟ್. ನೋಡಿ ಇಲ್ಲಿ, parturition is induced by complex neuroendocrine mechanism. The signal for parturition originates from the fully developed fetus and placenta. ಅಲ್ಲಿಂದ ಬರುತ್ತೆ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. which induces mild uterine contraction called fetal ejection reflex. ಬಂತ? ನೆಕ್ಸ್ಟ್, this triggers release of oxytocin from the middle pituitary. ಆ ಕಾಂಟ್ರಾಕ್ಷನ್ ಬಂದ ತಕ್ಷಣನೇ from the pituitary ಇಂದ there is a release of oxytocin. ನೋಡಿ, oxytocin acts on the uterine muscles and causes stronger contraction. contraction strong ಆಗುತ್ತೆ ಆಮೇಲೆ ಮತ್ತೆ, ಸರಿನಾ? which in turn stimulates further secretion of oxytocin. so first oxytocin ಬಂತಾ, ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಯ್ತು. ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗಿದ ತಕ್ಷಣ ಮತ್ತೆ ಆಕ್ಸಿಟೋಸಿನ್ ಬಂತು, ಮತ್ತೆ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಯ್ತು, ಮತ್ತೆ ಆಕ್ಸಿಟೋಸಿನ್, ಮತ್ತೆ ಕಾಂಟ್ರಾಕ್ಷನ್. ಆ ಥರ ಆಗ್ತಾ 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 ಬೇಬಿ ಆಚೆ ಬರುತ್ತೆ. ಇದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್, ಇದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್. ಮುಂಚೆ ಕೇಳಿದ್ದಾರೆ ನಿಮ್ಗೆ ಇದನ್ನ, ಸರಿನಾ? ಇದು ಕೂಡ ಪ್ಲಾಸೆಂಟಾ ಬಗ್ಗೆ ಎಲ್ಲ ಸತಿ ಕೇಳ್ತಾರೆ ಸ್ಟೂಡೆಂಟ್ಸ್. ಹೇಳಿ ನನಗೆ ಕಮೆಂಟ್ ಅಲ್ಲಿ, ವಾಟ್ ಆರ್ ದ ಹಾರ್ಮೋನ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಬೈ ಪ್ಲಾಸೆಂಟಾ? ಬೇಗ ಹೇಳಿ ನನಗೆ, ವಾಟ್ ಆರ್ ದ ಹಾರ್ಮೋನ್ಸ್? ಓಕೆ ಸರ್, ಫುಲ್ ಕ್ವೆಶನ್ಸ್ SPR ಹ್ಯಾಂಡ್ ಬುಕ್ ಅಲ್ಲಿ ಇದೆ. ಹ್ಯಾಂಡ್ ಬುಕ್ ಅಲ್ಲಿ ಇದು ಇದೆ ಬೇಕಾರೆ, ಸರಿನಾ? ಲಾಂಗ್ ವಿಡಿಯೋಸ್ ಮಾಡೋದ ನೆಕ್ಸ್ಟ್ ವೀಕಲ್ಲಿ, ಬರೋ ವೀಕಲ್ಲಿ ನೀವು ನೋಡ್ತೀರಾ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಲೇಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ನಾವು ಮಾಡ್ತೀವಿ ನೋಡಿ. ಇವತ್ತು ಬೆಳಗ್ಗೆ ನಾನು ನೀಟ್ ಮಕ್ಳಿಗೋಸ್ಕರ 2 hour 2.5 hours 3 hours ಕ್ಲಾಸ್ ತೊಗೊಂಡಿನಿ ಬೆಳಗ್ಗೆ. ಇವತ್ತು 3 hour ಕ್ಲಾಸು. ನೀವು ಕೂರ್ತೀರಾ 3 hours? ಬೇಗಳಿ ನನಗೆ, ಕೂರ್ತೀರಾ 3 hours ಒಂದು ಚಾಪ್ಟರ್ಗೆ? ನೀವು ಕೂರ್ತೀರ, ನಾವು ಹೇಳ್ಕೊಡ್ತೀವಿ, ನಮಗೇನಿಲ್ಲ. ನೆನ್ನೆ ನಾವು ಗೋಪಿಕಾ ಮ್ಯಾಮು ನಿಮ್ದು ಎಂಟೈರ್ ಹ್ಯೂಮನ್ ಫಿಸಿಯಾಲಜಿನ 4 hour ಕ್ಲಾಸ್ ತೊಗೊಂಡಿದ್ದೀವಿ ನಾವು. ನಮಗೇನಿಲ್ಲ ಲಾಂಗ್ ಕ್ಲಾಸ್ ಮಾಡೋದಕ್ಕೆ, ನಾವು ಲಾಂಗ್ ಕ್ಲಾಸ್ ಮಾಡ್ಬೋದು, ನಮ್ಗೆ ಇಷ್ಟ ಲಾಂಗ್ ಕ್ಲಾಸ್ ಮಾಡೋದಕ್ಕೆ. ಬಟ್ ನೀವೆಲ್ಲ ಕೂರ್ತೀರಾ ಲಾಂಗ್ ಕ್ಲಾಸ್ ಮಾಡಿದ್ರೆ, ಅದು ನಾವು ಕೇಳಬೇಕಾಗಿರೋದು. ಕೂರ್ತೀರಾ 3 hour 2 hour ಒಂದು ಚಾಪ್ಟರ್ಗೆ? ಕೂರ್ತೀರಾ 2 hour ಒಂದು ಚಾಪ್ಟರ್ಗೆ? ನೀವು ಹೂ ಅನ್ನಿ ಕಮೆಂಟ್ ತಿಳಿಸಿ ನನಗೆ, ಸರ್ ಹೂ ಸರ್ ನಾನು ಕುತ್ಕೋತೀನಿ 2 hour ಆದ್ರಿ 3 hour ಆಗಲಿ ನೀವು ಅಂದರೆ ನಾವು ಮಾಡ್ತೀವಿ ಲಾಂಗ್ ವಿಡಿಯೋಸು. ಯಾಕಂದರೆ ನಮ್ಗೆ ಏನನ್ಸಿರೋದಂದರೆ, ನಾವು ಶಾರ್ಟ್ ವಿಡಿಯೋಸ್ ಮಾಡಿದ್ರೆ ನೀವು ನೋಡ್ತೀರಾ ಅಂತ ಮಾಡ್ತಿರೋದು ನಾವೀಗ. ಎಕ್ಸಾಕ್ಟ್ಲಿ. ಪ್ಲಾಸೆಂಟಾ ಇಂದೇನು? HPL, ಹ್ಯೂಮನ್ ಪ್ಲಾಸೆಂಟಲ್ ಲ್ಯಾಕ್ಟೋಜನ್, ಹ್ಯೂಮನ್ HCG, ಹ್ಯೂಮನ್ ಕೊರಿಯಾನಿಟಿಕ್ ಗೋನಾಟ್ರೋಪಿನ್, ಎಸ್ಟ್ರೋಜನ್, ಪ್ರೊಜೆಸ್ಟಿರಾನ್ ಅಂಡ್ ರಿಲ್ಯಾಕ್ಸಿನ್. ಈ ಎಲ್ಲ ಹಾರ್ಮೋನ್ಸು ಪ್ಲಾಸೆಂಟಾಯಿಂದ ಬರುತ್ತೆ. ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್. ಓಕೆ, ರಿಲ್ಯಾಕ್ಸಿನ್ ಕೂಡ ಮಾಡುತ್ತೆ. ಸೇಮ್ ಕ್ವೆಶನ್ ನೋಡಿ, ಸೇಮ್ ಕ್ವೆಶನ್. ಮತ್ತೆ ಮೆನ್ಷನ್ ದ ಫಂಕ್ಷನ್ ಪ್ಲಾಸೆಂಟಾ, ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವೆಶನ್ ಇದು, ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವೆಶನ್. ಓಕೆ, ರೆಡಿ? ಇದು ನೋಡಿ, ಈ ಕ್ವೆಶನ್ ಕೇಳಿಸ್ಕೊಳ್ಳಿ, ಈ ಕ್ವೆಶನ್ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ವಾಟ್ ಈಸ್ ದ ಸೆಕ್ಸ್ ಡಿಟರ್ಮಿನೇಷನ್ ಇನ್ ಹನಿ ಬಿ? ತುಂಬಾ ಒಳ್ಳೆ ಕ್ವೆಶನ್, ಬ್ಯೂಟಿಫುಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ, ಕರೆಕ್ಟಾಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ ಈಗ, ಸರಿನಾ? ಹನಿ ಬಿಯಲ್ಲಿ ಸೆಕ್ಸ್ ಡಿಟರ್ಮಿನೇಷನ್ ಹೆಂಗಾಗುತ್ತೆ ಅಂದ್ರೆ, ಸೊ ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಯು ವಾಟ್ ಈಸ್ ಮೇಲ್ ಹೆಟ್ರೋಗ್ಯಾಮಿಟಿ, ಫೀಮೇಲ್ ಹೆಟ್ರೋಗ್ಯಾಮಿಟಿ. ಸ್ಟೂಡೆಂಟ್ಸ್ ನಂಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡಿ ಬೇಗ ಕಮೆಂಟ್ ಅಲ್ಲಿ. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಮೇಲ್ ಹೆಟ್ರೋಗ್ಯಾಮಿಟಿ, ಮೇಲ್ ಹೆಟ್ರೋಗ್ಯಾಮಿಟಿಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡಿ ಬೇಗ. ನಾವು ಇದನ್ನ ಹೇಳ್ಕೊಡ್ತೀನಿ ನಿಮಗೆ. ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಹನಿ ಬಿ, ಆ ಸೆಕ್ಸ್ ಡಿಟರ್ಮಿನೇಷನ್ ಹೆಂಗಾಗುತ್ತಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಮೇಲ್, ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಫೀಮೇಲ್. ಓಕೆ, ಯೂಶಲಿ ಮೇಲ್ಸ್ ಆರ್ ಹ್ಯಾಪ್ಲಾಯ್ಡ್, n is equal to 16 here. In the case of female, 2n is equal to 32. Okay, now students, this is the ploidy of the organism. Ploidy of the organism. Illi male is n, female is 2n. ಈ ಮೇಲು ಸ್ಪರ್ಮ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ, ಇಲ್ಲಿ ಎಗ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಎಗ್. ದ ಪ್ಲಾಯ್ಡಿ ಹಿಯರ್ ಇಸ್ n is equal to 16. ಈ ಸ್ಪರ್ಮ್ ಕೂಡ n equals 16. ನಾವು ಸ್ಟೂಡೆಂಟ್ಸ್ ನಂಗೆ ಬೇಗ ತಿಳಿಸಿ ಎಲ್ಲ ಕಮೆಂಟ್ ಅಲ್ಲಿ, ಇಫ್ ಫೀಮೇಲ್ ಅಲ್ಲಿ ದಿಸ್ ಇಸ್ 2n, ಗ್ಯಾಮೆಟ್ ಇಸ್ n, ಇಲ್ಲಿ ನಾನೀಗ ಮೈಟೋಸಿಸ್ ಬರಿಬೇಕಾ ಇಲ್ಲ ಮಿಯೋಸಿಸ್ ಬರಿಬೇಕಾ ಅಂತ ಬೇಗ ಹೇಳಿ ನನಗೆ, ಬೇಗ ಹೇಳಿ. ಸಿ, ಈ ಚೇಂಜ್ ಇನ್ ಪ್ಲಾಯ್ಡಿ ಬರೀ ಮಿಯೋಸಿಸ್ ಇಂದ ಮಾತ್ರ ಸಾಧ್ಯ, ಮಿಯೋಸಿಸ್ ಇಂದ ಮಾತ್ರ ಸಾಧ್ಯ ಇದು. ಓಕೆ, ನಾವು ವಾಟ್ ಅಬೌಟ್ ಹಿಯರ್? ಇಲ್ಲಿ ಮೈಟೋಸಿಸ್ ಆಗುತ್ತೆ, ಮೈಟೋಸಿಸ್ ಮಾತ್ರ ಆಗುತ್ತೆ ಇಲ್ಲಿ, ಸರಿನಾ? ಇದು ಎರಡು ಫ್ಯೂಸ್ ಆದ್ರೆ ಇಟ್ ವಿಲ್ ಆಲ್ವೇಸ್, ರಿಮೆಂಬರ್ ವೆರಿ ಕೇರ್ಫುಲಿ, ಇಟ್ ವಿಲ್ ಆಲ್ವೇಸ್ ರಿಸಲ್ಟ್ ಇನ್ ಫೀಮೇಲ್. ಯಾಕಂದ್ರೆ n plus n is 2n, n plus n is 2n, so 2n ಆಗುತ್ತೆ ಯಾವಾಗೂ. ಸೊ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಹನಿಬೀಸ್ ಅಲ್ಲಿ ಯಾವತ್ತೂ ಕೂಡ ಫರ್ಟಿಲೈಸೇಷನ್ ಆದ್ರೆ it will always result in a female. ಈ ಫೀಮೇಲ್ ಬಿ ಇದೆಯಲ್ಲ, ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಅ ಕ್ವೀನ್ ಆರ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಅ ವರ್ಕರ್ ಬಿ. ನಾವು ನೀವು ಯೋಚನೆ ಮಾಡ್ತಾ ಇರ್ಬೇಕು, ಸರ್ ಇಲ್ಲಿ ಫೀಮೇಲ್ ಬಂತು, ಬಟ್ ಹೌ ಆರ್ ಮೇಲ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಹಿಯರ್? ಮೇಲ್ಸ್ ಹೆಂಗ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಹನಿ ಬೀಸ್ ಅಲ್ಲಿ? ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಈ ಎಗ್ ಇದೆಯಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್, ಈ ಎಗ್ ಇಲ್ಲಿ, ದಿಸ್ ಎಗ್ ವಿಲ್ directly develop, this egg here directly develops into the male, ಡೈರೆಕ್ಟ್ ಆಗಿ ಮೇಲ್ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. n ಇದೆಯಾ, ಮೇಲು ಕೂಡ n ಇರುತ್ತೆ. You might ask me, sir, ಹೆಂಗ್ ಸಾಧ್ಯ ಇದು, this process? The process here is called as parthenogenesis. Parthenogenesis ಇಂದ ಈ process ಸಾಧ್ಯ. So in the case of sex determination honeybee, male, female, male will always undergo mitosis to produce the sperm, female will always undergo meiosis to produce the egg. When they fuse together, it will always result in female. Males are produced directly from the egg, males are produced. Idu sex determination honeybee. So now the sex determination is mainly based on the number of chromosome or a set of chromosome. Females ಅಲ್ಲಿ ಯಾವತ್ತು ಡಿಪ್ಲಾಯ್ಡ್ ಇರುತ್ತೆ, ಮೇಲ್ಸ್ ಅಲ್ಲಿ ಯಾವತ್ತು ಹ್ಯಾಪ್ಲಾಯ್ಡ್ ಇರುತ್ತೆ. ಸರಿನಾ? ಸ್ಟೂಡೆಂಟ್ಸ್, ಇದು ನಿಮ್ಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋದು ಬೇಕಾಗಿಲ್ಲ, ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಗೊತ್ತಿದ್ದು. ದಿಸ್ ಇಸ್ ಅ ಡೈಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್, ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಗೊತ್ತಲ್ಲ ಡೈಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್. ಈ ಥರನೇ ಬರೀಬೇಕು ನೀವು, ಎಕ್ಸಾಮಲ್ಲೂ ಕೂಡ ಈ ಥರನೇ ಬರೀಬೇಕು. ಪೇರೆಂಟ್ಸ್, ಗ್ಯಾಮೆಟ್ಸ್, F1, ಸೆಲ್ಫಿಂಗ್ ಆಫ್ F1 ಈ ಥರ ಬರೀಬೇಕು. ಈ ಥರ ಡ್ರಾ ಮಾಡ್ಬೇಕು, ನೀವು ಫುಲ್ಲು ಡ್ರಾ ಮಾಡ್ಬೇಕು ಈ ಥರ. ಇಲ್ಲಿ ಫಿನೋಟಿಪಿಕ್ ರೇಷಿಯೋ ಏನು, ಜಿನೋಟಿಪಿಕ್ ರೇಷಿಯೋ ಏನು? ಜಿನೋಟಿಪಿಕ್ ನಿಮ್ಗೆ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿಲ್ಲ, ಸೊ ಡೋಂಟ್ ಹ್ಯಾವ್ ಟು ವರಿ. What is the phenotypic ratio? 9:3:3:1. ಇದು ನಿಮ್ದು ಡೈಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್. ಡೈಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್ನ ನೀವು ಕಲಿಲೇಬೇಕು, ಈಸಿಯಾಗಿ ಒಂದು ಕ್ವೆಶನ್ ಬಂದೇ ಬರುತ್ತೆ. ಎಂಟೈರ್ ಡೈಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್ ಈ ಥರನೇ ಬರೀಬೇಕು ಫುಲ್ಲು. ಈ ಥರ ನೋಡಿ, ಸೆಲ್ಫಿಂಗ್ ಆಫ್ F1, ಗ್ಯಾಮೆಟ್ಸ್, ಪೇರೆಂಟ್ಸ್, ಈ ಥರ ಬರೆದ್ರೆ ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ. ಸರಿನಾ? They can ask you what is law of independent assortment. ಏನಪ್ಪ ಇಂಡಿಪೆಂಡೆಂಟ್ ಅಸಾರ್ಟ್ಮೆಂಟ್ ಅಂದ್ರೆ, ಇಂಡಿಪೆಂಡೆಂಟ್ ಅಸಾರ್ಟ್ಮೆಂಟ್ ಅಂದರೆ ವೆನ್ ಇನ್ ಅ ಹೈಬ್ರಿಡ್, ಇದು ನಿಮ್ಮ ಹೈಬ್ರಿಡ್ ಆಯ್ತು, ಇದು ಹೈಬ್ರಿಡ್ ಆಯ್ತು, ಹೈಬ್ರಿಡು. ದಟ್ ಈಸ್ ವೆನ್ ದೇರ್ ಇಸ್ ಅ ಹೈಬ್ರಿಡ್ ಹಿಯರ್, segregation of one character is independent of other character. Seed shape separate ಆಗೋದು, seed color separate ಆಗೋದು, both are independent. seed color separate ಆಗುತ್ತೆ, seed shape separate ಆಗುತ್ತೆ, ಎರಡು intermix ಆಗಲ್ಲ. That is independent assortment. ಇದು ಕೂಡ ನಿಮ್ದು ಮೋನೋ ಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್, ಇದು ಫುಲ್ ಮೋನೋ ಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್, ಈ ತರನೇ ಬರೀಬೇಕು ಫುಲ್ಲು. ಇಲ್ಲಿ ಫಿನೋಟಿಪಿಕ್ ರೇಷಿಯೋ ಇನ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಬೇಗ ಹೇಳಿ ನಂಗೆ. What is the phenotypic ratio? Tall, tall, tall. 3. 1 short. So 3:1 is phenotypic ratio. What is the genotypic ratio? Bega heli nange. Homozygous dominant, heterozygous, homozygous recessive. So ಇದು ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕಿದು. ಸೊ ಇದನ್ನ ನಿಮಗೆ ಮೋನೋ ಹೈಬ್ರಿಡ್ ಕ್ರಾಸ್ನ ನೀವು ಬರೆದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಇದನ್ನ ನೋಟ್ಸ್ ನಿಮಗೆ ಕೊಡ್ತೀನಿ. ಈ ಥರನೇ ಬರೀಬೇಕು, ಈ ಥರನೇ ಬರೀಬೇಕು. ಸೇಮ್ ಡಿಕ್ಟೋ ಕಾಪಿ ಮಾಡಿ, ಡಿಕ್ಟೋ ಕಾಪಿ ಮಾಡಿ ಸರ್ನಾ. ಡಿಕ್ಟೋ ಫುಲ್ ಈ ಥರನೇ ಕಾಪಿ ಮಾಡ್ಬೇಕು ನೀವು. ಸ್ಕೋರ್ ಇದು ಬಿಟ್ರೆ ನಿಮಗೆ ಇನ್ಕಂಪ್ಲೀಟ್ ಡಾಮಿನೆನ್ಸ್ ಕೇಳ್ತಾರೆ. ವಾಟ್ ಈಸ್ ಇನ್ಕಂಪ್ಲೀಟ್ ಡಾಮಿನೆನ್ಸ್? ಎದರಲ್ಲಾಗುತ್ತೆ? ಇಟ್ ಹ್ಯಾಪನ್ಸ್ ಇನ್ ಸ್ನ್ಯಾಪ್ ಡ್ರ್ಯಾಗನ್ ATM ಸ್ಪೀಶೀಸ್ ಅಲ್ಲಾಗುತ್ತೆ ಸರ್ನಾ. ಅದು ಬಿಟ್ರೆ ವಾಟ್ ಇಸ್ ದ ಫಿನೋಟಿಪಿಕ್ ರೇಷಿಯೋ, ವಾಟ್ ಇಸ್ ಜಿನೋಟಿಪಿಕ್ ರೇಷಿಯೋ ಇಯರ್, ಆ ಥರ ಕೇಳ್ತಾರೆ ನೋಡಿ. ಇಲ್ಲಿ ನಿಮಗೆ F1 ಯಾವತ್ತು ಪಿಂಕ್ ಕಲರ್ ಫ್ಲವರ್ ಬರುತ್ತೆ, ಪಿಂಕ್ ಕಲರ್ ಫ್ಲವರ್, ಪಿಂಕ್ ಕಲರ್ ಫ್ಲವರ್. ವೈ? ಬಿಕಾಸ್ ದಿಸ್ ಜೀನ್ ಇಸ್ ಇನ್ಕಂಪ್ಲೀಟ್ ಡಾಮಿನೆಂಟ್ ಓವರ್ ದ ಅದರ್. ಸರಿ, ದಿಸ್ ಅಲೀಲ್ ಇಸ್ ಇನ್ಕಂಪ್ಲೀಟ್ ಡಾಮಿನೆಂಟ್ ಓವರ್ ದ ಅದರ್. ಸೊ ಅದಕ್ಕೆ ಇಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ ಆರ್ ಸ್ಮಾಲ್ ಆರ್ ರೆಡ್ ಬರಲ್ಲ, ಇಲ್ಲಿ ನಿಮಗೆ ಪಿಂಕ್ ಬರುತ್ತೆ. ಸೊ ಇಲ್ಲೇನು, ಇದು ರೆಡ್ ಇರುತ್ತೆ, ರೆಡ್ ಕಂಪ್ಲೀಟ್ಲಿ, ಇದು ಪಿಂಕು, ಇದು ಕೂಡ ಪಿಂಕು ಸರ್ನಾ. So to tell me students, what is the phenotypic ratio awaga? What is the phenotypic ratio? 1 is red, 2 is pink, 1 is white. Idu white irutte, white. Okay. What is the genotypic ratio here students? Genotypic ratio 1 homozygous, 2 heterozygous, 1 more homozygous. So 1:2:1, 1:2:1. ಇದು ತುಂಬಾ ಫೇಮಸ್ ಕ್ವೆಶ್ಚನ್, 5 ಮಾರ್ಕ್ ಈಸಿಯಾಗಿ ಕೇಳ್ತಾರೆ ಯಾವಾಗೂ. ಇದು ಕೂಡ ಡ್ರಾ ಮಾಡ್ಬೇಕು ನೀವು, ಈ ಥರ ಫುಲ್ ಡ್ರಾ ಮಾಡ್ಬೇಕು ಇದನ್ನ ಸರ್ನಾ. ಓಕೆ, ನಿಮ್ದು ಮೈಕ್ರೋಬ್ಸ್ ಅಂತ ಏನು ಕೇಳ್ಬೋದು, ಇದು ನಿಮಗೆ ಆಗಲೇ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ಇನ್ನ 2 ಮಾರ್ಕಲ್ಲಿ ನೋಡಿ, ಮೈಕ್ರೋಬ್ಸಲ್ಲಿ ನಿಮ್ಗೆ ಅವರು ಈ 2 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್ ಇತ್ತಲ್ಲ, 2 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸು ಅದನ್ನ ಎಲ್ಲ ಕಂಬೈನ್ ಮಾಡಿ ಈ ಥರ ನಿಮಗೆ 5 ಮಾರ್ಕಿಗೆ ಕೇಳ್ಬೋದು. ಡಿಫ್ರೆಂಟ್ ರೋಲ್ ಆಫ್ ಮೈಕ್ರೋಬ್ಸ್ ಇನ್ ಹೌಸ್ ಹೋಲ್ಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್. ಎಲ್ಲಿ ಕರ್ಡ್ ಫಾರ್ಮೇಷನ್ ಯಾವ ಬ್ಯಾಕ್ಟೀರಿಯಾ, ಲ್ಯಾಕ್ಟಿಕ್ ಆಸಿಡ್. ಡೋ ಫಾರ್ಮೇಷನ್ ಏನು, ಸೆಕ್ಯಾರಮೈಸಿಸ್, ಬ್ರೆಡ್, ಈಸ್ಟ್ ಎಲ್ಲ. ಚೀಸ್ ಫಾರ್ಮೇಷನ್ ಅಲ್ಲಿ ಪ್ರೊಪ್ಯೂನಿಬ್ಯಾಕ್ಟೀರಿಯಂ ಶರ್ಮಾನಿ, ಸ್ವಿಸ್ ಚೀಸಲ್ಲಿ. ಓಕೆ, ಬ್ರೂವಿಂಗ್ ಅಲ್ಲಿ ಈಸ್ಟ್ ಮತ್ತೆ ಆ ಥರ. ಸೊ ಈ ಥರ ಕೇಳ್ಬೋದು ಮತ್ತೆ ನಿಮ್ಗೆ ಆ ಥರ ಸೇಮ್. ಈ ಕ್ವೆಶನ್ ತುಂಬ ಜಾಸ್ತಿ ಕೇಳಿದ್ದಾರೆ. ಅದು ಬಿಟ್ಟರೆ ದೇ ಕೆನ್ ಆಸ್ಕ್ ಯು ಎಕ್ಸ್ಪ್ಲೇನ್ ದ ರೋಲ್ ಆಫ್ ಮೈಕ್ರೋಬ್ಸ್ ಇನ್ ಸೀವೇಜ್ ಟ್ರೀಟ್ಮೆಂಟು. ವಾಟ್ ಈಸ್ ಪ್ರೈಮರಿ ಟ್ರೀಟ್ಮೆಂಟ್, ವಾಟ್ ಈಸ್ ಸೆಕೆಂಡ್ ಟ್ರೀಟ್ಮೆಂಟ್? ಸಿಂಪಲ್ ಆಗಿ ಕೇಳ್ತೀನಿ, ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಪ್ರೈಮರಿ ಟ್ರೀಟ್ಮೆಂಟಲ್ಲಿ ಎಲ್ಲ ಫಿಸಿಕಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ನ ರಿಮೂವ್ ಮಾಡ್ತೀವಿ, ಅದೇ ನೀವು ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟ್ ಏನಾಗುತ್ತೆ, ಸೆಕೆಂಡರಿ ಟ್ರೀಟ್ಮೆಂಟಲ್ಲಿ ನಾವು ಬಯೋಲಾಜಿಕಲ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಯೋಲಾಜಿಕಲ್ ಮೆಥಡ್ ಅಂದ್ರೆ ಏನು? ಅಲ್ಲಿ ನಾವು ಬ್ಯಾಕ್ಟೀರಿಯಾನ ಯೂಸ್ ಮಾಡಿ ಎಲ್ಲ ಆರ್ಗನಿಸಮ್ಸ್ ತೆಗಿತೀವಿ. ದಟ್ ಇಸ್ ಬಯೋಲಾಜಿಕಲ್ ಮೆಥಡ್. ಓಕೆ, ಇದು ಕೂಡ ಫೇಮಸ್ ಕ್ವೆಶನ್. ಬಯೋಗ್ಯಾಸ್ ಅಲ್ಲಿ ಏನು, ಯಾವ ಥರ ಮೈಕ್ರೋಬ್ಸ್ ಇದೆ, ದಟ್ ಇಸ್ ಮೆಥಾನೋ ಬ್ಯಾಕ್ಟೀರಿಯಾ. ಬಯೋಗ್ಯಾಸ್ ಅಲ್ಲಿ ನಿಮಗೆ ಮೇನ್ಲಿ ಈ ಡಯಾಗ್ರಾಮ್ ಗೊತ್ತಿರಬೇಕು. ಏನಾಗುತ್ತೆ ಡಯಾಗ್ರಾಮ್ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ನಿಮ್ದು ಇಲ್ಲಿ ಶಗಣಿ, ದಟ್ ಇಸ್ ಕೌಡಂಗ್ನ ನೀರ್ ಜೊತೆ ಮಿಕ್ಸ್ ಮಾಡಿ ಇಲ್ಲಿ ಹಾಕ್ಬೇಕು. ಹಾಕ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, ಎಲ್ಲ ಇಳಿದೋಗಿ ಇಲ್ಲಿ ಬರುತ್ತೆ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಡೈಜೆಸ್ಟರ್. ಈ ಡೈಜೆಸ್ಟರ್ ಅಲ್ಲಿ ದೇರ್ ಇಸ್ ನೋ ಆಕ್ಸಿಜನ್ ಅಟ್ ಆಲ್, ದಟ್ ಇಸ್ ನೋ O2 ಇಲ್ಲ. ಸೊ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಈ ಡೈಜೆಸ್ಟರ್ ಅಲ್ಲಿ ಈ ಕೌಡಂಗಲ್ಲಿ ಇರೋ ಎಲ್ಲ ಸೆಲ್ಲೋಸ್ನ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಯೂಸ್ ಮಾಡಿ ಏನಾಗುತ್ತೆ, ಎನ್ಏರೋಬಿಕ್ ರೆಸ್ಪಿರೇಷನ್ ಆಗುತ್ತೆ. ಎನ್ಏರೋಬಿಕ್ ರೆಸ್ಪಿರೇಷನ್ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. ಒನ್ ಆಫ್ ದ ಬೈ ಪ್ರಾಡಕ್ಟ್ಸ್ ಆಫ್ ಎನ್ಏರೋಬಿಕ್ ರೆಸ್ಪಿರೇಷನ್ ಇಲ್ಲಿಂದ ಆಚೆ ಬರ್ತಾ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ಮೇನ್ಲಿ ದ ಬಯೋಗ್ಯಾಸ್ ಇಲ್ಲಿಂದ ಆಚೆ ಬರ್ತಾ ಇರುತ್ತೆ. ಸರಿನಾ? ಬಯೋಗ್ಯಾಸ್ ಆಚೆ ಬರ್ತಾ ಇರುತ್ತೆ. ನಾ ಆರ್ಗನಿಸಮ್ ಪಾಪ್ಯುಲೇಷನ್ ಯಾವ ಥರ, ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ದಿಸ್ ಎಂಟೈರ್ ಕ್ವೆಶನ್. ಡಿಸ್ಕ್ರೈಬ್ ದ ಪಾಪ್ಯುಲೇಷನ್ ಅಟ್ರಿಬ್ಯೂಟ್ಸ್, ಎನಿ 4 ಆಫ್ ದಮ್. ಇಲ್ಲಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕಿದ್ದು ಎಲ್ಲಪ್ಪ ಡಯಾಗ್ರಾಮ್ ಅದು ಇದು ನೋಡಿ, ಪಾಪ್ಯುಲೇಷನ್ ಆಟ್ರಿಬ್ಯೂಟು. ಒಂದು ಪಾಪ್ಯುಲೇಷನಲ್ಲಿ ಏನಾದರೆ ಪಾಪ್ಯುಲೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಏನಾದರೆ ಪಾಪ್ಯುಲೇಷನ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಒಂದು ಪಾಪ್ಯುಲೇಷನಲ್ಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ನೆಟಾಲಿಟಿ ಅಂದರೆ ಬರ್ತ್ ಆಗೋದು, ಹೊಸ ಜೀವ ಬರೋದು, ಬರ್ತ್ ಆಗೋದು. ಮಾರ್ಟಾಲಿಟಿ ಅಂದರೆ ಸಾಯೋದು. ಸತ್ರೆ ಪಾಪ್ಯುಲೇಷನಿಂದ ಲೆವೆಲ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಯಾರೋ ಬದುಕು ಬಂದರೆ ಪಾಪ್ಯುಲೇಷನ್ ಲೆವೆಲ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇಮಿಗ್ರೇಷನ್ ಅಂದರೆ ಪಾಪ್ಯುಲೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಎಮಿಗ್ರೇಷನ್ ಅಂದರೆ ಪಾಪ್ಯುಲೇಷನ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಈ ಡಯಾಗ್ರಾಮ್ನ ಮಾಡಿಬಿಟ್ಟು ಈ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ನೀವು ಬರೆದ್ರೆ ಈಸಿಯಾಗಿ 5 ಮಾರ್ಕ್ಸ್ ನಿಮ್ಗೆ ಕೊಡ್ತಾರೆ, ಅವರು 5 ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. ಸರಿನಾ? ಇಲ್ಲಿ ನಾನು ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ಎಲ್ಲದಕ್ಕೂ ಎಕ್ಸಾಂಪಲ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಸರಿನಾ? ಹಾಂ, ಇದನ್ನ ನಾನು ನಿಮಗೆ ನೆನ್ನೆ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೆ, ನೆನಪಿದೆಯಾ? 3 ಮಾರ್ಕಲ್ಲಿ ಈ ಕ್ವೆಶನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೆ. 3 ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಪಾಪ್ಯುಲೇಷನ್ ಪಿರಮಿಡ್ಸ್, ದಟ್ ಈಸ್ ಬೆಲ್ ಶೇಪ್, ಪಿರಮಿಡ್ ಶೇಪ್ ಆ್ಯಂಡ್ ಆರೆಂಜ್ ಶೇಪ್, ಎಕ್ಸ್ಪ್ಯಾಂಡಿಂಗ್, ಸ್ಟೇಬಲ್, ಡಿಕ್ಲೈನಿಂಗ್. ಪಾಯಿಂಟ್ಸ್ ಕೊಡಿ, ಇವತ್ತು ಪಾಯಿಂಟ್ಸ್ ಕೊಡಿ ನೋಡಿ ನಿಮಗೋಸ್ಕರ ಪಾಯಿಂಟ್ಸು. ಮತ್ತೆ ಅದು ಬಿಟ್ಟರೆ ಇದನ್ನು ಕೂಡ ನಿಮಗೆ ನಾನು 3 ಮಾರ್ಕ್ ಕ್ವೆಶನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ ನೋಡಿ. ಗ್ರೋತ್ ಕರ್ವ್, ಸರಿನಾ? ಲಾಜಿಸ್ಟಿಕ್ ಮತ್ತು ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್. ನಿಮ್ಮದು ಎಕೋಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಇದು ಒಂದೇ ಕ್ವೆಶನ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಎಕೋಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಈ ಕ್ವೆಶನ್ ಬಿಟ್ಟರೆ ಯಾವುದೂ ಇಲ್ಲ. ಎಕೋಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಈ ಕ್ವೆಶನ್ ಬಿಟ್ಟರೆ 5 ಮಾರ್ಕ್ಸ್ ಅನ್ನಷ್ಟು ಯಾವುದು ಕ್ವೆಶನ್ ಬರಲ್ಲ ಇಲ್ಲಿ. ದಟ್ ಇಸ್ ಡಿಕಂಪೋಸಿಷನ್, ಏನೇನು ಪ್ರಾಪರ್ಟೀಸು, ಫ್ರಾಗ್ಮೆಂಟೇಷನ್, ಲೀಚಿಂಗ್, ಕ್ಯಾಟಬಾಲಿಸಮ್, ಹ್ಯೂಮಿಫಿಕೇಶನ್, ಮಿನರಲೈಸೇಷನ್. ಎಲ್ಲದಕ್ಕೂ 1 ಪಾಯಿಂಟ್ ಬರೆದ್ರೆ ಸಾಕು, 1 ಪಾಯಿಂಟ್ ಬರೆದ್ರೆ ಸಾಕು ಅಷ್ಟೇ. ಸರಿನಾ? ಇದು ಮೇನ್ ಎಲ್ಲಕ್ಕಿಂತ ತೋರಿಸ್ತೀನಿ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್. ಈ ಕ್ವೆಶನ್ ನೋಡಿ, ಹಾಂ, ಇದು ಕೂಡ ಒಂದು ಫೇಮಸ್ 5 ಮಾರ್ಕ್ ಕ್ವೆಶನ್. ಇದು ಫೇಮಸ್ 5 ಮಾರ್ಕ್ ಕ್ವೆಶನ್. ಏನಪ್ಪ ಇದು? ದಟ್ ಈಸ್ ಲಾಸ್ ಆಫ್ ಬಯೋಡೈವರ್ಸಿಟಿ. ವಾಟ್ ಆರ್ ದ ಮೇನ್ ರೀಸನ್ಸ್? ಇಲ್ಲಿ ನಿಮಗೆ ಈವಲ್ ಕ್ವಾಡ್ರೇಟ್ ಅಂತ ಬರುತ್ತೆ. ಈವಲ್ ಕ್ವಾಡ್ರೇಟ್, ದೇರ್ ಆರ್ 4 ಮೇನ್ ರೀಸನ್ಸ್ ಹಿಯರ್ ಈವಲ್ ಕ್ವಾಡ್ರೇಟ್ ಅಲ್ಲಿ. ಯಾವುದು? ಫಸ್ಟ್ ಒನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಫ್ರಾಗ್ಮೆಂಟೇಷನ್, ಹ್ಯಾಬಿಟೇಟ್ ಲಾಸ್ ಅಂಡ್ ಫ್ರಾಗ್ಮೆಂಟೇಷನ್. ಒಬ್ಬರದು ಮನೇನ ಕಿತ್ಕೊಂಡ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ? ಅದು ಫ್ರಾಗ್ಮೆಂಟೇಷನ್. ಎಕ್ಸಾಂಪಲ್ ನಮ್ಗೆ ಕೊಟ್ಟಿದ್ದೀವಿ ನೋಡಿ, ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದೀವಿ. ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ಗೆ ಎನ್ಸೈಡಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಅಮೆಝಾನ್ ರೈನ್ ಫಾರೆಸ್ಟ್ ಡಿಸ್ಟ್ರಾಯ್ ಆಗ್ತಾ ಇರೋದು ಫಾರ್ ಸೋಯಾಬೀನ್ ಕಲ್ಟಿವೇಶನ್. ಅದಾದಮೇಲೆ ಓವರ್ ಎಕ್ಸ್ಪ್ಲೋಟೇಷನ್ ಅಂದ್ರೆ ಏನು? ಓವರ್ ಎಕ್ಸ್ಪ್ಲೋಟೇಷನ್ ಅಂದರೆ ಒಂದು ಸ್ಪೀಷೀಸ್ ನಾವು ತುಂಬ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ. ದಟ್ ಈಸ್ ಸ್ಟೆಲ್ಲಾರ್ ಸೀ ಕೌ ಮತ್ತು ಪ್ಯಾಸೆಂಜರ್ ಪಿಜನ್. 2 ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಮೇನ್ ಎಕ್ಸಾಂಪಲು. ಈ 2 ಪ್ರಾಣಿನ ನಾವು ಎಷ್ಟು ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ ಅದ್ರದ್ದು ಪಾಪ್ಯುಲೇಷನ್ ಫುಲ್ ಕಮ್ಮಿ ಆಗೋಯ್ತು. ಓವರ್ ಎಕ್ಸ್ಪ್ಲಾಟೇಷನ್. ನೀವು ಯೋಚನೆ ಮಾಡಿರ್ಬೇಕಿನ್ನ, ನೀವು ದಿನಕ್ಕೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಒಂದು ದಿವಸದಲ್ಲಿ ನೀವು 2 ಅವರ್ ಟಿ ವಿ ನೋಡ್ತೀರಾ. ಅದೇ ನಿಮ್ಮ ಪ್ಯಾರೆಂಟ್ಸ್ ಮನೇಲಿ ಇಲ್ಲ ಅಂದ್ರೆ ಏನು ಮಾಡ್ತೀರಾ? 4 ಅವರ್ 5 ಅವರ್ ನೋಡ್ತೀರಾ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಸ್ ಎಕ್ಸ್ಪ್ಲಾಟೇಷನ್. ಟೈಮ್ ನೀವು ಬಿಟ್ಟಿದ್ದಕ್ಕೆ ಟೈಮ್ ನೋಡಿ ನೀವು ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡ್ಬಿಡ್ತೀರಲ್ಲ, ಅದು ಓವರ್ ಎಕ್ಸ್ಪ್ಲಾಟೇಷನ್. ಅದು ಬಿಟ್ಟರೆ ದೇರ್ ಇಸ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಆಸ್ ಏಲಿಯನ್ ಸ್ಪೀಶಿ ಇನ್ವೇಷನ್. ಇಲ್ಲಿ ನಾವು ಬೇರೆ ದೇಶದಿಂದ ನಮ್ಮ ಕಂಟ್ರಿ ಒಳಗಡೆ ಬೇರೆ ಥರದ್ದು ಪ್ರಾಣಿ ಇಲ್ಲ ಪ್ಲಾಂಟ್ ಬರ್ತಾ ಇದೆ. ಇದು ನೋಡಿರ್ಬೋದು ನೀವು ರೋಡ್ ಸೈಡಲ್ಲಿ ಕಾಂಗ್ರೆಸ್ ಗಿಡ ಇಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪಾರ್ಥೀನಿಯಂ. ಅದು ಬಿಟ್ಟರೆ ಐಕಾರ್ನಿಯಾ, ಅದು ಬಿಟ್ಟರೆ ಲ್ಯಾಂಟಿನಾ ಕೆಮೆರಾ. ಇದೆಲ್ಲ ಬೇರೆ ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಇಲ್ಲಿ. ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ ನೈಲ್ ಪ್ರೀಚ್ ಅಂತ ನೋಡಿ, ನೈಲ್ ಪ್ರೀಚ್ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ. ಲ್ಯಾಂಟಿನಾ ಕೆಮೆರಾ, ಕಾಂಗ್ರೆಸ್ ಮತ್ತು ಐಕಾರ್ನಿಯಾ. ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ ಕೋ ಎಕ್ಸ್ಟೆನ್ಷನ್. 4 ಮೇನ್ ಈವಲ್ ಕ್ವಾಡ್ರೇಟ್ ಇಲ್ಲಿ. ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ ಕೋ ಎಕ್ಸ್ಟೆನ್ಷನ್. ಕೋ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಏನಾಗ್ತಂತಂದರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯೋಚನೆ ಮಾಡಿ, ಒಂದು ಪ್ಲಾಂಟ್ ಇದೆ, ಆ ಪ್ಲಾಂಟಿಗೆ ಒಂದು ಬಟರ್ಫ್ಲೈ ಬಂದು ಪಾಲಿನೇಷನ್ ಮಾಡ್ತಾ ಇದೆ. ಯೋಚನೆ ಮಾಡಿ, ಅಕಸ್ಮಾತು ಆ ಬಟರ್ಫ್ಲೈ ಸತ್ತೋಗ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ? ಆ ಪ್ಲಾಂಟು ಸತ್ತೋಗುತ್ತೆ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಕೋ ಎಕ್ಸ್ಟೆನ್ಷನ್, ಒಟ್ಟಿಗೆ ಸತ್ತೋಗೋದು. ಓಕೆನಾ? ಸೊ ಆ ಥರ ನಿಮಗೆ ನಾನು ಎವ್ರಿ ಸಿಂಗಲ್ ಚಾಪ್ಟರಿಂದ ಮೇನ್ 5 ಮಾರ್ಕ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ತೋರಿಸಿದ್ದೀನಿ. ಸರ್ನಾ? ಈಗ ನಾವು ನೆಕ್ಸ್ಟ್ ವೀಕಲ್ಲ, ಈ ವೀಕಿಂದಾನೆ ನಾಳೆ ನಿಮ್ಗೊಂದು ಸ್ಪೆಷಲ್ ವಿಡಿಯೋ ಬರುತ್ತೆ, ಅದನ್ನ ಚೆಕ್ ಮಾಡಿ ಒಂದ್ಸತಿ. ಸರ್ನಾ? ಅಲ್ಲಿ ನಾನು ನಿಮ್ಮದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ನಿಮ್ಮದು ಎಂಟೈರ್ ಎಕಾಲಜಿನ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ನಾಳೆ ಬರುತ್ತೆ, ಸೊ ನೋಡಿ ಅದನ್ನ. ಸರ್ನಾ? ಅಲ್ಲಿ ನಾನು ನಿಮಗೆ ಎಲ್ಲ ಥರದ್ದು ಟಾಪಿಕ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಡೀಟೇಲ್ ಆಗಿ. ಲಾಂಗ್ ವಿಡಿಯೋ ಬರುತ್ತೆ. ಸರ್ನಾ? ಸೊ ಈ ಎಲ್ಲ ಕ್ವೆಶನ್ಸ್ನ ನೀವು ಟೈಮ್ ಕಮ್ಮಿ ಇರೋದ್ರಿಂದ ನಿಮಗೆ ಈ ಕ್ವೆಶನ್ ನಾನು ಇವತ್ತು PDF ಆಗಿ ಕೊಡ್ತೀನಿ, ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ನೋಟ್ಸ್ನ ಓದಿ. ಸರ್ನಾ? ಎಲ್ಲೇ ಏನೇ ಡೌಟ್ ಬಂದರೆ ನನಗೆ ಕಮೆಂಟ್ ತಿಳಿಸಿ, ನಾನು ನಿಮಗೆ ಲಾಂಗ್ ವಿಡಿಯೋಸ್ ಕೊಡ್ತೀನಿ, ಅವಾಗ ಇದೆಲ್ಲ ಈಸಿ ಆಗುತ್ತೆ. ಸರ್ನಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಈಗ ನಿಮ್ಮದು ನಿಮಗೂ ಮ್ಯಾಥ್ಸ್ ಮ್ಯಾಮ್, ಕೆಮಿಸ್ಟ್ರಿ ಮ್ಯಾಮ್ ಬರ್ತಾರೆ. ಕೆಮಿಸ್ಟ್ರಿ ಮ್ಯಾಮ್ ವಿಲ್ ಟೇಕ್ ದ ಕ್ಲಾಸ್. ಆ್ಯಂಡ್ ಅಂಟಿಲ್ ದೆನ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಟೇಕ್ ಕೇರ್ ಆಲ್ ಆಫ್ ಯು. ಬಾಯ್. ಮಾಲಿಕ್ಯುಲರ್ ಬೇಸಿಸಿಂದ ನಿಮ್ಮದು ಗೋಪಿಕಾ ಮ್ಯಾಮ್ ನಾಳೆ ಮಾಡ್ತಾರೆ ಕ್ಲಾಸು. ಮಾಲಿಕ್ಯುಲರ್ ಬೇಸಿಸು, ಹ್ಯೂಮನ್ ಹೆಲ್ತ್ ಡಿಸೀಸು, ಆಮೇಲೆ ಬಯೋಟೆಕ್ನಾಲಜಿ, ಈ ಮೇನ್ 3 ಎವಲ್ಯೂಷನ್ ಕೂಡ ನಿಮ್ಮದು ಈ ಮ್ಯಾಮ್ ಮಾಡ್ತಾರೆ, ಗೋಪಿಕಾ ಮ್ಯಾಮ್ ಮಾಡ್ತಾರೆ ನಾಳೆ. ಫುಲ್ ಲಾಂಗ್ ಕ್ಲಾಸ್ ಇದೆ ನಾಳೆ, ಲಾಂಗ್ ಕ್ಲಾಸ್ ಇದೆ ನಿಮ್ಮದು ನಾಳೆ ಒಂದು, ಸರಿನಾ? ಸೊ ನಿಮ್ದು ಕೆಮಿಸ್ಟ್ರಿ ಮ್ಯಾಮ್ಗೆ ಒಂದು ಫೋನ್ ಹಾಕ್ಬಿಡೋದ ಈಗ, ಸರಿನಾ? ಅಮೃತ ಮ್ಯಾಮ್, ಗೋಪಿಕಾ ಮ್ಯಾಮ್ ಕೊಡ್ತಾರೆ ಅದನ್ನ. ನಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿ ಮ್ಯಾಮ್ಗೆ ಒಂದು ಫೋನ್ ಹಾಕೋದ, ಸರಿನಾ? ಸೊ ಅಲ್ಲಿವರೆಗೂ ವೆಯ್ಟ್ ಮಾಡಿ. ಇಲ್ಲಪ್ಪ ನಿಮ್ಮ ಮ್ಯಾಮ್ ನಂಬರ್ ಸಿಗ್ತಾ ಇಲ್ಲ. ಒಂದು ನಿಮಿಷ ಸ್ಟೂಡೆಂಟ್ಸ್.
Okay, so hi everybody. Now we are going to start with the chemistry part. So let us start that without wasting any time. Okay, so the first question on your screen is, why is CO bond length in phenol less than methanol? So if you talk about phenol here, this is phenol, right? We know that in phenol there is partially double bond character due to resonating structures here, right? And talking about methanol here, methanol has single bond between carbon and oxygen. That means we know that double bond is less in length as compared to single bond. That is the reason CO bond length in phenol is less than methanol. You can also see the proper theory based answer here. Due to resonance of CO bond acquires some partial double bond. So in phenol, CO bond length is smaller than methanol, right? Okay. Next is, arrange the following in the order of increasing order of the boiling points. Okay, let's arrange it in that order. This is ethoxy ethane, that is CH3. I'll just write the answers. I'll just write the structures here. CH3, or you can say ethane, na? So C2H5, this is O, this is C2H5, right? Then you have butanol. Butanol means C4, there will be, so 1, 2, 3, 4, and here you will have CHO. Butanol means 1, 2, 3, 4, and here you will have OH. N-butane means 1, 2, 3, 4. Okay. So now, can you see one thing here, that they are asking about the boiling point. So we know that in butanol there is hydrogen bonding. So maximum boiling point should be there. So maximum will be of butanol. Okay. After that, if you talk about butanol, it does it as compared to butanol, definitely it has high hydrogen bonding. That is why there will be because of that hydrogen bonding, there will be forces of attraction will be very strong. But in case of butanol, there will be this kind of bond. Now here there will be no hydrogen bonding, right? Because hydrogen bonding, the hydrogen should be attached to the electronegative element. But here what will happen, there will be, because of the electronegativity difference, because of this oxygen, there will be interactions because of the polarity, right? Okay. Next is ethoxyethane. Now what is ethoxyethane? That is ROR. In this case, again there will be interaction because of the polarity. But in case of butanol, the interactions, the oxygen is on the terminal position. That's why the interactions will be larger as compared to the ether, right? Last one is butane, where there is simple van der Waals interactions, no polarity based interactions. Okay, so answer is going to be, this is the correct answer. Okay, next is, how can phenol be prepared from anisole, right? So if you talk about anisole here, so let us just draw this structure. This is anisole, that is OCH3. You add HX here, what will happen? This bond will break, and here you will have the attachment of X, and here you will have the attachment of H. You will have the formation of phenol and alkyl halide. Okay, next is, how do you convert the following? How do you convert the following? So it's a very, very important thing. How do you convert the following here? So basically what will happen? Phenol to picric acid, propanone to 2-methyl propane 2-ol, phenol to anisole, propene to propane 1-O. Okay, so now let us see this. First is phenol. We are converting phenol to picric acid. So what we have to do? Just add concentrated HNO3, right? High nitration. Because of high nitration, that ortho, because OH, phenol is a ortho, because of the lone pairs over here, it is a ortho para directing group. Okay, so there will be orthopara positions will have the attack of NO2 positive electrophile, right? Next is you have the formation of what was there in the question. In the question it was propanone to 2-methyl propane tool. Propanone is this one to 2-methyl propane tool. So basically what we are doing here, 3, 4, we are increasing the number of carbon atoms here. So how you increase the number of carbon atoms in a carbonyl compound? By adding Grignard reagent. Okay, so you have to see what you need to make. For that is the reason we will react this with Grignard reagent. Then what will happen? This will be the double bond O. What will happen here? This is negative, this is positive. This negative part will attack here. Electrons will jump, and here there will be MgBr. That's why you have the formation of MgBr here, and here you have the attachment of one more. You have the attachment of one CH3 over here. So carbon will have one CH3, other CH3, and third CH3 over here, and there will be one OMgBr over here, and this is the thing. After that, just do the hydrolysis. This OMgBr will be converted to OH, and hence you will have your answer, right? Okay. Next question, guys, on your screen is phenol to anisole. Now it is opposite. Phenol to anisole you have to prepare. Now if you have, this to we have done, na? This we have not done. Phenol to anisole, basically what you have to do, first you react this with NaOH. H will be replaced by Na. After that, this is ONA. This is basically alkoxide, or you can say phenoxide. Just give me a second. Okay. So this is basically alkoxide or phenoxide, right? Now, this is Williamson synthesis reaction. What is a Williamson synthesis reaction, guys? Anybody? Beta, anybody? Williamson synthesis is when you have RONA and RX, this will combine to form ROR. Okay, so what has happened? This thing and this thing has combined to form anisole. That is Williamson synthesis reaction. Okay, then next one is propene to propane 1-ol. Okay, so what is propene to propane 1-ol? This is propene 1-ol. Beta 1-ol. 1-ol means you have to substitute OH over here. So there are two, basically if you have to, that means OH negative part is getting attached to more number of hydrogen. That means here you are applying anti-Markovnikov addition. Anti-Markovnikov addition you are applying here, and that is the reason you break this double bond and attach OH on the more number of hydrogen. If you want to apply Markovnikov addition, right, basically Markovnikov addition will be done either by acidic hydration, but acidic hydration has carbocation formation. So sometimes it does not give the product of Markovnikov addition, but oxymercuration, demercuration always is direct Markovnikov rule. Okay, Markovnikov means less number of hydrogen, negative part to less number of hydrogen. Okay, next is write the IUPAC name for the following organic compound. Write the IUPAC name, guys, here. IUPAC name of the following, is this given to you? Yes, that is given to you. So on N, you have one methyl, you have one this. Take any of this as the main chain. Okay, so what I'll take this as a main chain, because in main chain, parent chain, you need to have more number of carbons. Okay, so that's why we have written here ethanamine. Okay, this is ethanamine. And on the N position, you have one methyl. Okay, N-methyl. On the N position, you have one ethyl. These are the substituents. So this is N-ethyl, N-methyl. E, because E in alphabetical order comes before M. So it is N-ethyl, E, then N-methyl. Okay, N will not tell you the alphabetical order. E and M will tell you the alphabetical order. Okay, next is write the equation for the following Gabriel phthalimide and Hoffman bromamide degradation. Okay, so Gabriel phthalimide reaction is when you have CO, NH, you're adding KOH. This H will be replaced by K. After that, you add any Ri here. That halide will be replaced here. This will be C2H5. Right? Because this is the positive part, this is the negative part. This is the positive part. Positive part will always be replaced by the other positive part. After that, you do the hydrolysis. This bond will break, this bond will break. Here you will have the formation of N. Here you will have the attachment of H, and here you will have the attachment of OH and OH. Hence you, or you can say ONA or ONA, right? And hence you will have the attachment of, right? You will have the formation of NH2C2H5 here, right? Okay, got it? Chalo. Next is C, RCONH2 Hoffman bromamide degradation. What will happen? This CO will be eliminated and hence you will have the formation of RNH2 here, right? By adding Br2 in presence of a base, right? Okay. Next question is what happens when D-glucose is treated with following reagents? D-glucose is treated with the following reagents. These reactions are very, very important. Firstly, the reactions, all the reactions of D-glucose are very important, okay? So, when D-glucose is treated with Br2 water, it's a very good oxidizing agent. What will happen? It will oxidize this CHO group to COH and you will have the formation of gluconic acid, okay? Next is when it is treated with HCN. With HCN, it is going to behave the same as HCN reacts with a carbonyl compound, okay? So, this is basically double bond O, right? And this is H, right? So, this is positive, this is negative. Negative part will attack here and this positive part will attack here. And here you will have the formation of COH and this will be CN, okay? So, COH, CHOH and CN will be formed. That is cyanohydrin will be formed here. Got it now? How we are doing this? C double bond O, you add HCN here. Same thing, positive, negative. Negative part will attack here, electrons will jump here. You will have the formation of CO. H will attach here because this will be negative. This will be 2 bonds and this will be CN over here. Same thing we have done in this case as well. And you have the formation of cyanohydrin here. Right, beta? These are very important questions, okay? Next is when you react this with acetyl anhydride. So, this acetyl group will replace all the OH groups here. So, what will happen? The OH over here, the OH over here, that will be replaced by OCOCH3. Or you can see this H will be replaced by C double bond OCH3. Okay, this H will be replaced by, I am saying, H will be replaced by C double bond OCH3. This will show us that there are 5 OH groups present in glucose structure, right? Okay. Now, let us do the 5 marks questions, guys. Let us start with the 5 marks questions. See, the difference in 5 marks and 3 marks question is maybe one more part they can ask you. In 3 marks, they will ask you 3 parts. In 5 marks, they ask you 4 parts and 5 parts of question, okay? So, that's the basic difference. So, even if you do 3 marks question, I have done it before. Same question can be asked in 5 marks. It's just that they will add one more reaction. That will become 5 marks question. Okay? Understood? Chalo. Now, let us do 5 marks question here. First is, as you can see here, 2 parts it is getting divided into. Give reasons for the following. First is, write a chemical test to distinguish between chlorobenzene, benzyl chloride, chloroform and carbon tetrachloride. So, let us see this, okay? You have to tell us the distinguish test here. If you talk about benzyl chloride, right? Benzyl chloride gives white precipitate with AgNO3. Okay? Why? Because benzyl chloride, you know, it's like CH2Cl. Okay? When it reacts with AgNO3, because of this Cl here, it will form AgCl. Right? So, AgCl is a white precipitate. So, white precipitate with AgNO3, while chlorobenzene, if you talk about chlorobenzene, in chlorobenzene, beta, this bond, because this bond is not partially, it has partial double bond character due to resonance. That is the reason this bond is very difficult to break. So, it will not react with AgNO3, right? Okay. So, chlorobenzene will not give that reaction. Here, this is a single bond, it is easy to break. This is a partial double bond, it is difficult to break. Right? Okay. Next is CHCl3 with aniline in presence of, now they are asking us the difference between, wait a minute, what is chloroform and carbon tetrachloride, that is CHCl3 and CCl4. Now, CHCl3 with aniline in presence of alcoholic KOH, that is carbylamine, not carbylamine, that is isocyanide test, or you can say carbylamine test for the test of 1 degree amines, right? In that we use CHCl3 and KOH. So that means when you have to see whether this is CHCl3, it with aniline in presence of this give foul smelling isocyanide, that is CHCl3 with aniline will give isocyanides, that is, it will give carbylamine test, but CCl4 will not give that test. Okay. Next is, it's a very interesting question. Okay. Why is methyl chloride hydrolyzed more easily than chlorobenzene? Okay. What is a methyl chloride? This is CH3Cl is hydrolyzed easily than C6H5Cl. Can you tell me the reason? Reason is same. Partial double bond character. This is beta basically chlorobenzene. That is like this. It will have resonance. This is simple CH3. You can also write it as CH3Cl. Right? Now, CHCl3 is hydrolyzed than this, as chlorobenzene has partial double bond character between CCl. Here it will have partial double bond character, which is difficult to break. But most of the questions are regarding this only. That's a, this is a very important concept. You can also say because phenyl cation is not stable here. This phenyl cation is not stable, right? That is also the reason why this bond we cannot break. Okay. Next is explain these two reactions. So we will just see the reaction directly. First reaction is they are saying that, wait a minute, they have given the reaction acidic solution. Okay. Explain this reaction. Okay. Chalo. Now, basically, now what they have given us 3 degree halide. And here they have given us ROH, right? Now, 3 degree halide undergoes SN1 reaction. Can you tell me why? SN1 reaction means it has a formation of carbocation. And carbocation 3 degree, then 2 degree, then 1 degree are stable, right? Carbocation stability is 3 degree, then 2 degree, then it is 1 degree is more stable here. Right, that is the reason we will write 3 degree, 2 degree, and then there will be 1 degree carbocation here, and hence we can easily write that this will show SN1 reaction, HBr, one of the products. Due to HBr, the solution will become acidic in nature because this will be formed here. This bond will break here. You will have the attachment of C2H5, right? C2H5O. Wait a minute. This is C2H5O. This will be attached here, hence you have the formation of HBr here, right? Okay, SN1 reaction it is 3 degree halide. Basically, this C2H5 will be attached here and you will have the elimination of HBr, which is acidic in nature. Next is, you have this particular is aryl halide, so it does not undergo nucleophilic reaction, hence it is, they are asking you why it is neutral. That's what they are asking this question, why it is neutral. Because there is no reaction that is happening here. Can you tell me why there is no reaction that is happening here? Aryl halide, basically this is the aryl halide, right? Aryl halide, we know that there will be partial double bond. Now, can we see, is there any drastic conditions that you can see here? No, there are no drastic conditions. CCl or CX bond is easy to break, but C partial double bond X is not easy to break, right? So that is why this will not undergo any reaction. This will undergo the reaction, hence it is a neutral medium, right? Okay, yes everybody. Next question is write the distinguished test for ethyl alcohol and 2-propanol. Ethyl alcohol, let me know in the comment section what is ethyl alcohol, guys. What is ethyl alcohol? Write the distinction test for ethyl alcohol and 2-propanol. So ethyl alcohol is this, 2-propanol is this, 1 degree and 2 degree. So there is one test called Lucas test, where you have ZnCl2 and HCl and hydrogen ZnCl2 and HCl. What exactly happens now? 3 degree will form turbidity easily, right? 2 degree after some time, 1 degree even after prolonged heating of 30 to 40 minutes, slowly it will start forming turbidity. So we consider it as no reaction only, right? If you can't, in chemistry, if you can't see the reaction like in some minutes, then that means that is a very slow reaction, right? That means it is almost a no reaction. Okay, next is of the two hydroxyl organic compounds ROH and R-OH, the first one reacts with acids and the other one reacts with bases to give salt. How is R different from R? First one reacts with acid, other one reacts with base. So, R is alkyl group, whereas R dash is the aryl group. Why so? Because if you talk about, let's say if you talk about CH3, let's say this is X. This is C, this is benzene, right? This is X. Now, when this reacts with acids, right? When this reacts with acid, it is going to react with acids. First one will react with acids easily because it is a single bond, it can easily break, right? Next is other one reacts with bases to give salt. How come? How come? If this reacts with bases, right? Wait a minute, this is RCl, ROX it is. Wait a minute, I'll just draw the wrong thing here. This will be CH3OH. This is OH. See, if it reacts with a base, that is NaOH, definitely we know that there is formation of phenoxide ion here. There is formation of phenoxide ion here. But if this reacts with acid, this reacts with acids like H2SO4 easily, right? Can you tell me the reason behind that? Because phenol is a greater acid as compared to any alkyl alcohol, right? Reason is because phenol shows a resonance. This does not show resonance. That is why, because phenol is more acidic in nature, that is why it will react with bases. Alcohol is less acidic in nature, that is why it will react with base. It will react with the acids because it is now behaving as a base. It can behave as a base in front of an acid. Got it? Okay. Next is why? What is absolute alcohol? Let us see what is absolute alcohol. Absolute alcohol is liquid alcohol that is at least 99% pure by weight, which is very, 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 very dangerous to drink. Okay, so the alcohol that people consume that has like around 4 to 5, maybe 10% maximum, right? I don't have exact idea. I think 4 to 5% maybe. So alcohol is actually a very dangerous thing. Inside our body, it will do some kind of reactions, right? So that's why not good for our body. Arrange the following set of compounds in order of their increasing boiling points. Now again a question on boiling points, right? So first is maximum is for pentane 1-ol because of hydrogen bonding. Then definitely there is aldehyde after that because of the polar interactions here. Then you have ether. Why this question is repeated, isn't it? Ether. Why? Because ether has less interaction as compared to aldehyde, right? Because R and R group are like, on left and right side. Inside there is one chotu sa oxygen group, right? And N-butane, it does not have any polarity of oxygen, any very electronegative element. That is why there is no strong interactions here, right? Next is explain how OH group attached to the carbon in benzene ring activates the benzene towards the electrophilic substitution reaction. This is what they are saying, how it is activating the ring because of the resonance. Lone pairs will shift here, electrons will shift here, negative charge, and this will be the positive charge. Again, electrons will shift here as a double bond. These double bond will shift here as negative charge. Again, this negative charge as double bond as negative charge, right? Again, negative charge as double bond as a neutral, which is going to neutralize the positive charge, and hence what you can see is at ortho and para position, you can see the negative charge here. That's why it is activating the ring, it is donating the ring here, right? Next is identify A, B, C in the following reaction. You have to identify A, B, C in the following reaction. Okay, ma'am. Now let us see that. CH3Br plus KCN. Okay, let's directly see the question here. Firstly, if you have CH3Br, it is going to replace this Br with the Cn. This is the negative part, positive part, right? Because it is ionic in nature, so it will be connected through C bond. If you have AgCN here, if beta I add AgCN here, then the answer would have been CH3NC. Okay, it's a very, very important question. CH3CN. After that, you reduce this because it has C triple bond N. So what will happen? 2 pi bonds will break, and hence you will have the addition of H2 here, because LiAlH4, lithium aluminium hydride, is a very good reducing agent, is a very, very good reducing agent. After that, add HNO3, which is basically HNO3 and at 273 Kelvin. So what will happen? You will have, now I'll just write it in the steps what you will have. You will have the formation of CH3, CH2, N2Cl positive negative, which is very unstable, so it is going to form the alcohol. Aryl disonium chloride, it is still stable at 0 to 5 degrees Celsius, but alkyl disonium chloride is not at all stable. And this is directly your NCERT question. It's a very, very important question. Okay, then you have basically you have CH3COH, you add NH3 here. OH will be replaced by NH2. After that, you add Br2KOH, Hoffman bromamide degradation. This will be vanished, and you will have the formation of CH3NH2. After that, you add CH3Cl3. This is nothing but this is carbylamine test. That is, this is isocyanide test. So because of this, you will have the formation of isocyanide, which is giving you the false smell. So this NH2 will be converted to NC here, right? Next is you have amides. Wait a minute, let me see the question here. What was the question? How are amines prepared from amides? Okay, very simple, beta. Hoffman bromamide degradation. You can just write that amines prepared from this. So you have two kind of things here. One is with the same carbon, other is degradation, one carbon less. If you want to make amine from the same number of carbon as in the amides, then what will happen? You just do the reduction with LiAlH4, CH2NH2 will be formed with the same number of carbon as there were in the amide, right? But here, if you want to prepare degraded product, that is one carbon less, so just do Hoffman bromamide degradation. This will be vanished out. You will have the formation of RNH2, right? Okay. Next is acetylation of amines with acid. Acetylation of amines with acid. Chloride is carried out in the presence of stronger base Y. Okay, let us see why. Okay, so beta, it's a very, very important reaction. So wait a minute, I have not written the answer here. So what I'll do, I'll just write the answer over here. Okay, so acetylation of amines with acid, chloride is carried out in presence of stronger base Y. So basically in acetylation, what happens? See, acetylation is when you have NH2, you replace one hydrogen with COCH3, you add CH3, C double bond O, right? Twice of, you can add acetyl chloride, you can add acetyl chloride or acetic anhydride, it's totally your choice. You just have to replace this COCH3 with the hydrogen on the nitrogen atom. Right, so this is N, this is H, this is C double bond O, CH3. Now they are asking why this is done in the presence of a very strong base called pyridine. So this is done in the presence of pyridine. The reason is because this is very, very basic in nature. This NH2 is also basic in nature. So with acetic anhydride, with acetyl chloride, what will happen? They both will react and give us acid-base reaction. So to avoid that, what we do, we add a stronger base as compared to aniline, that is pyridine, to stop that process so that we can have the desired product here. Right? Okay guys, chalo. Done. Next is, how is glucose prepared? How is glucose prepared? Let us see. From sucrose, the hydrolysis of sucrose, glucose and fructose will be prepared. From starch also, because starch is a polysaccharide. So after adding water in acidic conditions at very high temperature and pressure, you will have the formation of n number of glucose. It is a polysaccharide, na, that is the reason. Sucrose is a disaccharide. So one glucose and one fructose will be formed. Fructose contains keto group but still reduces tolerance reagent. Why? What is the reason behind that? In diluted alkaline solution, fructose undergoes isomerization to glucose via mannose. That is the reason it will show. Even though it is ketonic group, even then, because ketone does not show tolerance test, only aldehyde should show tolerance test. Then why fructose is showing? Because fructose is getting converted into glucose, right, via mannose. That is why reduces tolerance reagent in Fehling solution, although it contains just keto group. It's a very, very important question. Okay, it's a very, very important question. Next is, what is essentially the difference between alpha form and beta form of glucose? Explain giving the structure. Okay, so now this is the structure. You just have to, remember the structure. Basically here, what is the difference here? So on the third position, wait a minute, CH2, CH, COH, COH, COH. Okay, so what we have observed, there is one thing is wrong written here. It should be one hydrogen. Okay, okay. So it should be one hydrogen over here. Yes. So basically what we can see here in alpha glucose, C1 is towards the right side. At C1 position, OH is towards the right side. But in beta, C1 will be at C1, OH is towards the left side. That is called anomers, or you can say epimers of each other. Basically, anomers are nothing but they are cyclic epimers. So this is in cycle, so that is why it is called anomer. Right? When at one chiral position, the OH or the configuration is opposite, that is called epimers, and cyclic epimers are called as anomers. Okay? Understood? Chalo. Next question, almost towards the last question, guys, here. So here it is, how does DNA replicate? Describe the mechanism of replication. How is the process responsible for preservation of heredity? Okay, so this is basically the process of replication, beta. In biomolecules, you have theory part as well. Replication is the process by which a single DNA molecule produces identical copies of itself, right, during cell division, right. During this process, the two strands of DNA, they are double helix. It's like this kind of strand. It's like this kind of strand. Wait a minute, let me just show you. It's like, it's like this kind of strand. Okay, this kind of strand you have, what will replicate, it will produce two identical strands here. Two strands of double helix first separate, and each separated strand then serve as a template for the synthesis of new strand. Okay, so what will happen? For example, this red part has separated out. Okay, this red part has separated out. This blue part has also separated out. Now what will happen? You will have the formation of new strand over here. Right, you will have the formation of new strand over here. That is called DNA replication. Okay, so due to specificity of base pair, the sequence in the two strand is complementary to each other. So there is basically one specificity, that G is always hydrogen bonded with C and A is always hydrogen bonded with T. So that is the specificity. Okay, okay. In other words, replication leads to production of two identical copies of DNA from the single parent of DNA, and a copy of each then passes on the new cells, resulting in cell division. Basically, how we have a DNA of our parents. Okay, so in this way, the heredity effects are transmitted from one cell to the other cell. Sometimes a kid, they can have the heredity things of their grandparents or great grandparents. How? Sometimes one gene will dominate, and sometimes they will not dominate. Okay, right? So that's why when you see Alia Bhatt's daughter, she has blue eyes, right? So it's like his great grandfather or great grandfather, I guess, he had blue eyes. Okay, so that's how heredity works, right? Okay, next question here is, how is the process responsible for preservation of heredity? This also would define the mechanism of replication. Acha, diagram hai na? This is the diagram. Dekho beta, CG, CG. Again, one more cell will be replicated that will have that kind of, that I have shown with this zigzag spiral thing. They have shown properly this diagram. Okay, next. Let me see the question here. Let me see. I think that was the question. How is responsible for this thing? Okay. Acha, this is basically other question that is basically not there, right? Okay, so I'll just erase this here, right? Okay, so that question was basically not there. By mistake, I have written it here. Okay, chal. Okay, then, guys, that's it for today. That was your questions, right? Okay, so I really hope you enjoyed the class. Then, bye bye. Take care. See you all. The PDF will be provided in the description box. Bye bye. Take care. Signing off. Tada. Hello.
All right, Ninja Warriors. Now is the time for 5 marker questions from mathematics, and we are going to get started quickly. You have successfully finished biology, and you're already done with chemistry part. Now is the time for mathematics, and after that, please do not go after mathematics also, because physics is going to be there after mathematics. So the very first question right here in front of your screen, you can clearly see 5 marker question. Understand that these questions might be easy or might be difficult, but the point is you have to understand how to present such questions. So that is why we are here for. So the very first question is coming from the world of probability. You can see that this question, a die is thrown. Okay, let me have a look at the chat box. All right. A die is thrown 6 times. If getting an odd number is a success, what is the probability of 5 success A part, at least 5 successes B part, at most 5 successes C part? Now you have to understand that probability of capital X equals to R, direct formula. is what? NCR, success, probability of success power N power R. How many success? R success. Probability of failure power N minus R, where P plus Q is going to be 1, and here P is nothing but probability of failure, Q is nothing but probability of success. Now this question is not very difficult. Understand one by one. A dice is thrown 6 times. So here the number of Bernoulli trial, this is a question from Bernoulli trial by the way. So number of Bernoulli trial, if you ask me how many times, n equals to 6, correct? If getting an odd number is a success, tell me one thing, if you have a dice, how many odd numbers will be there? Ma'am, 3 odd numbers, 1, 3, 5. And how many total numbers will be there on a dice? Total outcomes, so 6 outcomes. So probability of getting odd is a success. P is probability of success. That is going to be 3 by 6. We can write it as 1 by 2. And probability of failure, that means not getting an odd number. Now, not getting an odd number means what? Getting an even number, right? So, even numbers are, ma'am, 2, 4, 6. 2, 4, 6 you can get. So, 3 by 6, again 1 by 2. So, probability of failure and success both are half and half. Half plus half is equals to 1. Now, part A we will do 5 successes, okay? So, probability of x equals to 5 is going to be n. N is 6, 6, C 5 and half power 5 and remaining half power 1. So, answer will be 6 by 2 power 6. So, this is going to give you 3 by 32 as your probability of x equals to 5. Okay, all right. Now, B part, let us quickly jump on to the B part. B part says that at least 5 successes. Now, understand, total how many successes you can get? Okay, so total how many? If you are throwing dice 6 times, so success you will get, maximum number of success you can get when every throw of dice will get you an odd number. Are you getting my point? The maximum 6 success you can get, right? So at least 5 success means what? Either 5 success or 6. So that means probability x greater than or equals to 5 is nothing but probability of x equals to 5 plus probability of x equals to 6. We cannot get 7 success because we are only throwing dice 6 times, right? So this is what? X equals to 5. So you have calculated now. 6C5, half power 5, half power 1. Now probability of 6 success will be what? 6C6, half power 6 and half power 0. So finally if you add this, your answer will be 6 plus 1, 7 by 2 power 6. This is your final probability of at least 5 success. Now at most 5 success. What is at most 5 success? What is this word at most? Can anybody tell me about the word at most? So part C, at most 5 success. At most 5 successes, okay? That means probability of x less than or equals to 5. Okay? Probability of x less than or maximum 5 success you can get. Or now, so if you go by calculation of this, then you have
not audible, huh? Abhi I am audible, right? Sorry, Saujanya. Okay. So now again I'll summarize.
So they are saying that 6 Bernoulli trial, probability of getting odd is a success. So probability of getting odd number on a dice is what? 3 by 6, 1 by 2. Probability of failure is also kya? Half. That means probability of getting an even number. Now this is your formula. Now probability A part. Probability of 5 success, x equals to 5. So 65 half power 5 and half power 1, 5 plus 1. So this is how what your answer is. Probability of 5 successes 3 by 32. Probability of at least 5 successes. At least 5 means 5 plus 6. So 5 plus 6. So 5 success, so we have just calculated 6 successes, 66 half power 6 and a half power 0. So this is what it is, 7 by 64, at least 5 success. Now probability of at most 5 success is nothing but 1 minus probability of 6 success. So 1 minus 66 half power 6 half power 0. So this is 63 by 64 for at most half success, 5 success. Now the next question. Next question is from the world of vector and 3D geometry combination. Derive the equation of a line in space passing through a point at parallel to vector in both vector and Cartesian form. Very good question, but very easy question as well if you know the drill. Okay, so this is your x-axis, this is your y-axis, and there is a z-axis also because it is a line in space. Okay, so z-axis is also there. X, y, correct, z. Now you have a line. Let me just draw this line in space. This is my line in space. Line L. Okay. Now this line, understand, is having a direction. Let us know that this is a B vector which is parallel to your line. Now you have to have a point also on the line. Let us assume that fixed point on a line is A vector. Point is A and the position vector is A. And one more thing, now there is a P vector which is nothing but an unknown vector R vector. Okay, so let me just define. You have a line L. Okay, line L. Line L is having a few things. Okay, number one, B vector is parallel to line. Correct? Okay, ma'am. Second thing, A vector or A is a point on the line. Known point on the line. Okay, 3. R vector, P point, or you can say R vector is, this is fixed point, this is unknown point on the line. Unknown point. Okay, so these are the equations which are given to you. Correct? Now just tell me one thing. Can I form AP vector? Yes, ma'am. AP vector is parallel to B vector. So can I write AP vector is lambda times B vector because AP is parallel to B vector. Correct or not? Now AP vector, if I just open it, AP vector will be what? OP minus OA just by position vector. That is going to be lambda times B. OP vector, can anybody tell me? OP is what? Oh, this is origin. OP vector will be what? R. R minus A vector is equals to lambda times B vector. This will give you R is equals to A plus lambda times B. This is your equation. Equation in vector form. Equation in vector form. Yes or no? Understanding it? Okay. Perfect. Clear. Alright. But ma'am, they are saying that Cartesian form also. So Cartesian form may just have a look. Now you have got your equation in vector form, correct? R vector is equals to A plus lambda times B vector. Okay, now Cartesian. Cartesian. R vector is an unknown point which is x I cap plus y j cap plus z k cap. A vector is a known point which is x1 I cap plus y1 j cap plus z1 k cap. B vector is nothing but A I cap parallel vector plus B j cap plus C k cap. Put the value right away. If you put it, x I cap plus y j cap plus z k cap is equals to x1 plus x1 I cap. plus lambda times b vector, which is a I cap plus b j cap plus c k cap. Okay? Yes, Karnataka. Okay. Now understand. Cartesian form. You just have to equate I component with I component. So x will be equals to x1 plus lambda a, comma y will be equals to y1 plus lambda b, z will be equals to z1 plus lambda c. So from every three equations you are getting, right? From all three equations calculate lambda. X minus x1 by a is equals to lambda. From here y minus y1 by b is equals to lambda. From here z minus z1 by c is equals to lambda. All three are lambda. This is the Cartesian equation of a straight line. Cartesian equation of a straight line. Getting it? Understanding it? Okay. Alright. Perfect. Now we are moving on to the next problem. Now this is a homework problem. Come on. This question though I have done tons of a time. Solution is already included. In previous video, if you have seen every video, we are doing this question. Very important question because this has come in, this is a PYQ basically. 5 marker question. So you can just check this out. Okay. I am moving forward and I am going to show you. Solve the following system of linear equation by matrix method. By matrix method. So here you need to understand, define matrix. There will be a matrix. Hold on. Color. There will be a matrix. A matrix will be nothing but a 3 cross 3 matrix formed by coefficient of x, y and z. So 3, minus 2 and 3. 2, 1 and minus 1. 4, minus 3 and 2. This is your A. X will be equals to what? X, y and z. And your B matrix will be equals to what? 8, 1 and 4. And now the equation which is written in algebraic form. This is your normal mathematics, right? But we are going to write this equation in matrix form. We have defined a matrix AX equals to B. If you multiply this matrix with this matrix AX, what are you going to get? 3 equations. This left hand side. Right hand side, this is the matrix you are going to get. So AX equals to B. What are you looking for? Tell me. Ma'am, we are looking for the values of X, Y and Z, which is very obvious. What is missing? X, Y and Z now. So calculate X, Y and Z. X, Y and Z, that means we are looking for this matrix. To calculate X, we just need to take A inverse B. Yes or no? How to find A inverse B? To find A inverse B, we have to find A inverse. A inverse is nothing but adjoint A upon determinant A. So here are the 2 steps. Actually, this question of matrix method consisting of 3 steps. One though is defining the matrix. That is no, I am not counting. Second step is writing X is equals to A inverse B. That is also I am not counting. Now, after this you have 3 steps. Step number 1. Define A inverse, which is adjoint A upon determinant A. Step number 1 is you need to calculate determinant A. Step number 2 is you have to calculate adjoint A matrix. Once you are done with A inverse, you have to multiply A inverse and B together. And once you are done with step number 3, multiplication A inverse B. Once you are done with this multiplication now, then easily you will get X. I'll show you the solution right away. See. Hold on. This is your A matrix. This is X. This is B. Correct? Now X is A inverse B. To calculate A inverse, we need to calculate adjoint. To calculate adjoint, we need to calculate cofactor matrix. What is adjoint? Transpose of cofactor matrix. So cofactor you have to calculate. So A11 you have to calculate. That means you have to hide this and this. 2 minus 3. 2 minus 3 is minus 1. Can you see? Okay. Then A12. A12. So A12 will be what? Tell me. This is A12. So 2 2s are 4 minus 4 plus 4. So this is A12. But negative sign will be there. Because 1, 2. Remember? Negative sign for this 1 and 2. So positive, then negative, positive, negative, positive, negative, positive, negative, positive. So these are what? Cofactor. Now you have to form cofactor matrix. So transpose, this is actually cofactor transpose. This is your determinant of A. Now this is your A inverse. A inverse is this. You have to multiply your A inverse with B. A inverse into B. The third step I was talking about. Just multiply. Do you know how to multiply matrix? Row, column, row, column, row, column. So minus 8, minus 5, minus 4, minus 17. Minus 64, minus 6 plus 36, minus 31. Minus 80 plus 1 plus 20 minus 51 is equals to 1, 2, 3. If you divide minus 1 by 17 with this, clearly you are going to get 1, 2 and 3. So your x, y, z is 1, 2 and 3. This is how you get the solution. This is heavy on calculation. You have to 5-marker question. 90% students will commit this mistake. So you have to practice these type of questions a lot. A lot means a lot. Now we are having this question. Let R plus be the set of all negative real number. Show that the function given by x square plus 4 is invertible and write the inverse of f. Now understand. Understand. Show that the function f R be the set, R plus be the set of R plus. This is all negative real numbers. Okay, all negative real numbers. Okay. So you put all negative real numbers and you get 4 to infinity. Set of all non-negative bolna chahiye na. Sorry, this is misprint. This should be all non-negative. Non-negative means what? Non-negative means what? That 0 is also there. So if you put 0, you will get 4. And so on. Okay, so non-negative. Fx is equals to x square plus 4. Okay. Now, so first of all, you have to show that function is invertible. Invertible means what? You have to show two things. Invertible means what? You have to show that the function is 1, 1 and then the function is onto as well. So first category, let us show the function is 1, 1. So x1 and x2 belongs to R plus set because domain is R plus. So we have taken two inputs. Now two inputs if I put, first input I will get f of x1 is equals to x1 square plus 4. F of x2, second output will be this. Both the outputs. Now we need to know whether both the outputs, see two input. So we need to know both the inputs are giving me what. So if both the if two different inputs are giving me same output now, then I can say okay, the function is many one, otherwise the function is going to be 1, 1. So I have taken two inputs, I have taken out two outputs. Now I am going to equate those two outputs. Can you see? This is how I equate the outputs. So 4 cancel, x1 square is equals to x2 square. So x1 is equals to plus minus x2. Now understand. That means two things we are getting. x1 is equals to x2. Second thing we are getting, x1 is equals to minus x2. Now tell me one thing, as per the question, that your input should always be non-negative, both. So if one is negative of other, so that simply means that if one is positive, other will be negative. So that is not possible. So we just need to understand that I tried to take two inputs and I realized that okay, output if I equate, then I should get a many one function, and I realized these two are not two different input but the same input. That means my function is 1, 1, number 1. Also now if I talk about whether my function is onto, very easy. X square plus 4. X square is a non-negative quantity. See, x square is always greater than or equals to 0. Now x square plus 4 is always greater than or equals to 0 plus 4. That means your function of x is greater than or equals to 4. Okay. Alright. Clear? So 1, 1 and this is on 2. Because your range, can you see range? and codomain are equal. So that is why this is onto. So now the function is invertible. Hence proved the function is invertible. You have to write because it is coming 1 1 and onto. Write the inverse of f. So now very easy. Y is equals to x square plus 4. Correct? How do we find inverse? What is the basic method? Y minus 4 is equals to x square. Then we are having x is equals to plus minus root y minus 4, but as per the question they are saying that non-negative. X can never be negative, so y is equals to root y minus 4. So your f of f inverse x is nothing but root x minus 4. So this is the correct answer of this particular question. Okay. All right. Okay. Alright, okay, perfect. Now we are having another question, okay, which is very basic question. I'll just let you know. Last question of the day, okay, after that physics will get started. So A matrix is given, B matrix is given and C matrix is given. Now we have to calculate AC, that means multiplication of this into this, number 1. Then we calculate BC, multiplication of B and C. And eventually you have to calculate A plus B multiply C. So you have to add them and then multiply it with C. So basically you have to understand why they are asking you to calculate 3 different matrix multiplication, because they want you to solve this. AC you have calculated, yes ma'am. BC you have calculated, yes ma'am. So AC plus BC you are going to do on the right hand side, and A plus B multiply C you are going to do on the right hand side. And you have to verify whether these are equal. So simple problem for matrix multiplication. So this is your A, B and C. AC will be A into C. So 0, 6, 7. So A matrix, C matrix. You know how to multiply matrix? Row 1, column 1. Can you see? Row 2, column 2. Row 3, column 3. Okay. So this is 9, 12 and 30. BC will be what? Row 1, column 1. Row 2, column 2, row 3, column 3. So this is your BC, correct? Now A plus B, so you add A and B, okay? So A and B, if you add, you will get this, and then multiply it with C. So again, row 1, column 1, row 2, column 2, row 3, column 1. So you are going to get this. So can you see that both 10, 20, 28, and if you add this, they are going to come same. So hence verified. Okay. Last question from mathematics PDF. You can find it in the description box. Now stay tuned because the session is not over yet. I'll ask your physics teacher Sandeep sir to take over this session. So wait for 5 seconds. He'll be right here. Okay. Bye bye. See you in the next.
Hello everyone, this is Sandeep Singh. Welcome back once again in your favorite channel. I hope you are doing very well, and we will going to discuss 5 marker question in this session. Let me know, is the audio and video proper or else any interruption? Let me know in the chat box. Hello. Okay. I think this time audio and video is proper. Let's start the session. Today we are going to discuss 5 marker question, which is right. Just wait. Let me check once. Yeah. Okay. Now it's clear. I think. Okay, fine. Let's start the session and discuss all these questions. And the session PDF is available in the description box. You can download with the link, right? Let's begin the session. Just put a thumbs up in chat box, then after we'll start the session. Just put a thumbs up in chat box, then we'll start the session, right? Yeah. Yep. Good. Very good. All right. Okay.
let's begin the session, right? This is basically 5-marker question. That means here is questions in the form of 4 sub questions, or numerical type question, or it's derivation type question, right? That means essay type questions, all right? See, okay, it's fine. Let's begin. Now, the first question is a rectangular hexagon of side 10 centimeter has charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of a hexagon, right? What it is? You just over your mathematics class, and it seems to be like mathematics class is going on right now also, right? See what it is. This is basically a hexagon, right? This is a hexagon and side is 10 centimeter, right? If I'm considering A, B, C, D, E, F, and this is the center, just join this one also. For hexagon, you know, these all are equilateral triangles. That means this side 10 centimeter, this is also 10, this is also 10, which means V is equals to KQ upon R into 6, just because we have hexagon, that means we have 6 number of charges, right? And electric potential is a scalar quantity, so that we can add up simply. Okay, now what it is? V is equals to 6 into 10 raised to the 6 into K, 9 into 10 raised to the power minus 9 into Q. Q is 5 microcoulomb, is it? 5 microcoulomb, which means 5 into 10 to the power minus 6 coulomb. This is 5 into 10 to the power minus 6 upon. What about 10 centimeter? R is basically 10 centimeter, which means 0.1, or you can write 10 into 10 to the power minus 2 meter, right? 10 into 10 raised to the power minus 2. Now, you can calculate the value of V, and let me know in the chat box what is the exact value of V. Let me know in the chat box. The value of V is. Alright? Right. This is 2.7 into 10 to the power. It is 2.7 into 10 to the power 6 volt. Right? Minus of 6, I think. This is 9, it's minus of 6. Right? Done. Now, moving to next. A 6 lead acid type secondary cell, each of EMF 2 volt and internal resistance of 0.15 ohm are joined in series to provide a supply of resistance of 8.5 ohm. What is the current drawn from the supply and its terminal voltage? Is it? Okay. See, 6 lead type secondary cell, each of 2 volt and the internal resistance given, right? See, these all are in series. I'm just solving portion A. These all are in series. Then in series combination, potential differences are just get add up. That means we have 6 cells, each of 6 volt, 2 volt. That means total EMF, which is equals to 6 into 2, that is 12 volt. Is it? Now, internal resistance, small r, 0.015 ohm. Now, are joined in the series to provide the supply to a resistor, that is capital R is 8.5 ohm basically. What is the current drawn from the supply and its terminal voltage? See, for V terminal, you have to calculate 12 upon. Basically, we have 6 lead cells, each having this much of internal resistance. That's why we can multiply 6 with this, right? That means 0.015 into 6. This is the terminal voltage. And what about the total current withdrawal from it? That is E upon NR times of E, which means 12 volt, NR that means this one. 6 into 0.015 plus external resistance. External resistance is 8.5. This is it. Just solve it and calculate the final answer. Is it? Just solve it and calculate the final answer. Okay? Okay. Let me know in the chat box. Is it? This is 11.87 and this is just you have to calculate. Now, a secondary cell after long use has EMF 1.9 volt and large internal resistance of 380 ohm. What is the maximum current can be drawn from the cell? Could the cell drive a starting motor of a car? In B portion, see, in B portion we have EMF of 1.9 volt, right? And a large resistance of 380 ohm. External resistance, this is 380 ohm. Okay. What is the maximum current can be drawn? Maximum current can be drawn, right? So maximum current, which is EMF upon resistance. EMF is 1.9 upon 380. If you remove this, this is basically 10. That is 1 upon 200, which means current 0.005 ampere. This is very small current. So that it can't drive motor of a car. This is a very small current, right? This is very small current. Okay, got my point. Okay. Now moving to next question. This is basically answer of this question. Now moving to next question. What it is? This is two concentric circle coils X and Y of radius 16 centimeter and 10 centimeter respectively lies in the same vertical plane containing the north to south direction. Coil X has 20 turns and carries a current of 16 ampere. Coil Y has 25 turns and carries a current of 18 ampere. The sense of the current X anticlockwise and clockwise in Y for an observer looking at a coil facing west. Give the magnitude and direction of the net magnetic field due to the coils at their center. You understand this question? This is, see, you have to calculate magnetic field intensity B, which is mu naught upon 2 pi, mu naught upon 4 pi 2I upon A. Is it? Mu naught by 4 pi 2I upon A. Alright. Basically, this formula is just written as mu naught upon 2, right? Ni upon A. Just because this comes from mu naught upon 4 pi. This value basically considered as 10 to the power minus 7. That's why it's given, right? Into 2 pi Ni upon A. 2 pi Ni upon A. 2 pi Ni upon A. Right? N is the number of turns, I is the current. This 2 pi driven 2. So I'm just using basic formula, that is mu naught upon 4 pi 2 ni 2 pi ni upon a. Is it? For both the coil, for x and y, both the coil. See, if I'm considering this is bx, then what it is? Mu naught upon 4 pi is 10 to the power minus 7. 2 into pi, this is 2 into pi. Okay. And number of turns in x, see, 6 centimeter respectively, same vertical plane containing north south. Coil x has 20 number of turns. This is number of turns. This is number of turns. That is, this is nx. This is 20. And ny. What about ny? It's having 25. Right? If I'm talking about ix current, 16 ampere. Ix is basically 16 ampere. And y is 18 ampere. That means Iy is equals to 20 ampere. Got my point? And what about A? What about A? What about A? See, this is 16 centimeter. AX is equals to 16 centimeter and AY is equals to 10 centimeter. AY equals to 10 centimeter. Now converted into meter, so that just multiply 10 to the power minus 2. Just multiply 10 to the power minus 2. This is in meter. Now you have to calculate BX. This is 10 to the power minus 7, 2 pi and 20. And what about IX? This is 16 upon A. A is what? 16 into 10 to the power minus 2. Right? 16 into 10 to the power minus 2. Is it? Is it? Is it? Now, let's calculate. Okay, just wait. This 4 times. This is 40 into pi and 10 to the power minus 5. Right? 10 to the power minus 5. Right? Then it is 40 pi into 10 to the power, sorry, 4 pi. This is 4 pi into 10 to the power minus 4. This is Px. And this is towards east. This is towards east. Okay, towards east. How will calculate east? Just because this current in x is anti-clockwise. Right? Now, I'm talking about By in the same form. This is say 10 to the power minus 7. Now 2 pi into, what about Ny? Ny is 25. Ny is 25. Then what about Iy is 20 upon A, which means 10 into 10 to the power minus 2. Right? Now it is 50 into this 100. Right? One more 0. This is pi and 10 to the power minus 1 comes about 10 to the power minus 6. Now compensate 1000 10 to the power minus 3. 10 to the power minus 3 pi. 10 to the power minus 3 pi. But we have to put into the format of 10 to the power minus 4 only. So. Just because we have to separate. So. 5 pi into 10 to the power minus 4. Is it? This is clockwise. That's why this is towards east, west. Now, you have two forces. One of them is, see, Bx is in this way and By is in this way. Bx is basically 4 pi into 10 to the power minus 4. This is 4 pi into 10 to the power minus 4. And this is 5 pi into 10 to the power minus 4. 5 pi into 10 to the power minus 4. Then Just subtract them. Just subtract them. Right? Done. Just wait. This is 2, 2, 5. This is 9 pi. Sorry. This is 9 pi into 10 to the power minus. This is 9 pi into 10 to the power minus 4. So. 9 pi into 10 to the power minus 4. Just subtract them. Then the final answer is 9 pi into 10 to the power minus 4 minus 4 pi into 10 to the power minus 4, which is equals to 5 pi into 10 to the power minus 4, and towards west. Final answer is towards west. B net in this way. B net in this way. Okay. Okay, fine. Now, moving towards question number 4. Figure, that is LCR circuit basically, connected variable frequency 230 and L equals to 5 Hertz, C equals to 80 and R equals to 40 ohm. Okay, determine the source frequency which drives the circuit resonance, right? Obtain the impedance of the circuit and amplitude of current at the resonating frequency, and determine the RMS potential drop across the 3 elements of the circuit so that the potential drop across the LC combination is 0 at resonating frequency. Let's see, first question. Firstly, we have to put, see, we have EMF of 230 volt, is it? What about L? L is basically 5 Henry. What about C? C is basically 80 microfarad. That means this is 80 into 10 to the power minus 6 farad. Is it? Now, what about R? R is basically 40 ohm. R is basically 40 ohm. Now, we have to calculate firstly a resonant angular frequency. A resonant angular frequency, right? A resonant angular frequency, omega naught, which is equals to under root of 1 upon LC, which is under root 1 upon under root of LC. Is it? Is it? Okay. Similarly, in this segment, you have to calculate IRMS, which is equals to ERMS upon R. ERMS upon R. Now you have to calculate peak current. Okay. Peak current, peak current, peak current. Peak current, that means I naught, which is equals to I naught, which is equals to IRMS upon root 2. Firstly, calculate IRMS, then IRMS upon root 2, then we will get peak current. Is it? Now we have to calculate. See, first, omega naught 1 upon under root of LC, that is 1 upon 5 into 80 into 10 to the power minus 6, that is 50 radian per second. Now, at resonance, impedance of LCR circuit simply equal to R. At resonance, Z equals to R equals to 40. Z equals to R equals to 40. RMS value 230 upon 40. 230 is basically EMF upon 40. That is 5.75 ampere. Now, as you see, I naught is equals to root 2 times of. Okay. Just wait now. Just wait. IRMS is equals to I naught upon root. Right. Now, we have to calculate I naught root 2 times of IRMS. That is 8.13 ampere. Now, the third part, the RMS potential drop, that is 5.75 into 40, that is 230 volt. Now, the RMS potential drop across inductor, that is IRMS omega naught L, that is 5.75. This is IRMS, omega naught is 50 and L is 5. This is 1437.5 volt. Now, the RMS potential drop across capacitor, it is IRMS into 1 upon omega naught C. IRMS is 5.75. 1 upon omega naught C, omega naught is 50 and C is 80 into 10 to the power minus 6. that is 1437.5. Now you have to see this and this. These are same value. These are same value. That means what? There is no potential difference between these two. That's why we can say the RMS potential drop across LC will be 0. RMS potential drop across LC will be 0, just because in both the cases RMS potential across L across C will be same. Okay. Now define the Brewster angle and hence derive at Brewster's law of polarization. We have to calculate Brewster's angle and derive the Brewster's law of polarization. See, the tangent of Brewster's angle IB is equal to the refractive index eta of material of the reflector, that is eta equals to tan IB. See, this is an incident ray, right? After reflection, this is reflected in this way and this is refracted. This is refracted, right? See, when the angle of incidence of a surface is equal to the Brewster angle, the reflected and refracted rays are perpendicular to each other. Brewster's angle, this is Brewster angle, then the angle of reflection and angle of refraction between these two ray angle is 90 degree. Right. Let's take a proof, right? See, consider a beam of unpolarized light incident at angle to Brewster's angle on the surface of a transparent material having refractive index, right? PU is the ray of light incident on the surface of the glass slab, refractive index N, and at angle IB, the Brewster angle, IB is the Brewster angle. Basically, this is IB is the Brewster angle. OQ, reflected ray which completely polarized. OR is the refracted ray and it's partially polarized. R be the angle of reflection. It is observed that reflected ray and refracted ray perpendicular to each other. These two are perpendicular to each other. Now we have to calculate mathematically. See, angle OQR, QOR, sorry. This is Q, this is O, and this is R. This is P. This is 90 degree. Right? Now, what it is? Now, see. This is 90 degree. This is equal to IB. Just angle of incidence is equal to angle of reflection. This is IB. Then can I see this total angle is 180 degree? Is it? Complete angle is 180 degree. MOQ QOR plus RON is equals to 180 degree. This is equals to IB. This is 90 degree and this is R, which is equals to 180 degree. R plus IB, that is equals to 90, just because R is equals to 90 degree minus IB. This R is equals to 90 degree minus IB. Right? Okay. From Snell's law, sin I upon sin R, sin IB upon sin R, right? Sin IB upon sin 90 minus IB, just because I is what? 90 minus IB. Then sin IB upon 90 minus IB, then sin IB upon cos IB. Sin IB upon cos IB is tan IB. That's why it's called eta equals to tan IB. This is Bristol. This is Bristol. Okay, this is Bristol. Okay. Now moving to next. Explain the construction and working theory of the transformer. See, it's very simple. What is transformer? This is basically two types. There is a two types, right? Step up and step down transformer. And how it will decide step up or step down? Then see, this is based on the Faraday's law, right? This is a core. This is a core. Now, this is called primary winding. This is called secondary winding. See, if I have the number of turns in primary, this is number of turns in secondary. If number of turns in primary is greater than number of turns in secondary, then it's called step down transform. This is step down transform. And if number of turns in primary is less than number of turns in secondary, then it is called step up transform. This is step up transformer basically. Here we put a AC supply. Transformer is not working on DC, right? If we putting here AC supply, then due to change in magnetic flux in primary coil, this will be linked into the secondary coil. This will be linked into secondary coil. Is it? Linked into secondary, right? Due to change in amplitude of the current, there will be change in magnetic flux continuously in secondary coil, and as we know, as per Faraday's law, an EMF induced across the secondary coil, that is VL basically, EMF induced across the secondary coil, due to which if I am considering any load resistance, then current passes through this load resistance. That means transformer, the principle of transformer is basically based on the mutual inductance, right? See, a transformer is a device used to step up or step down AC voltages. It work on the principle of mutual inductance, right? Construction part, I hope completed, right? A transformer consists of two sets of coils insulated of each other. They are wound on a soft iron core, either one of the top of the other or on the separate limbs of the core as figure. These are the separate limbs, right? See, NP, see, called primary coil has NP turns. The other hand, coil is called the secondary coil. It has number of turns, NS number of turns. Primary coil is the input coil and the secondary coil is the output coil of the transformer. Is it working? When an alternating current voltage applied to a primary, resulting current produces an alternating magnetic flux which links the secondary and induces an EMF. Links in secondary and induce EMF. The value of its EMF depends on the number of turns in the secondary coil. Value of current is depends on the number of turns in secondary coil, right? Working where when alternating voltage is applied to the primary coil, the resulting current produces and the alternating magnetic flux which links in the secondary and induce an EMF in it. The value of this EMF depends on the number of turns in the secondary, right? See, theory and expression. See, EMF of secondary coil is basically number of turns in secondary into rate of change of flux, d phi upon dt. And what about primary? That is EP equals to negative of NP d phi upon dt. What it is? This is Lenz's law. Negative sign comes from Lenz's law and this is basically Faraday's law, right? Now, for an ideal transformer, what it is? See, where Vs, that is Ns d phi upon dt and Np d phi upon dt. This is potential across secondary and primary. Now, dividing these two by these two. That means Vs upon Vp equals to Ns upon Ap is equals to a constant, that is T. It's called turn ratio. T is the turn ratio. See, right hand side same for EMF and for potential difference, right? Similarly, we have to calculate efficiency of transformer. Efficiency of transformer is just basically 100%, right? That means for an ideal transformer, number of turns secondary is equals to number of turns in primary, so that 100% efficient. But it is not possible at all, just because you have many losses occur, just like copper loss, hysteresis loss, flux linkage, right? And eddy current loss also. So, moving to next, what is an AC generator? Give the principle of generator, derive the expression for generation sinusoidal EMF by an AC generator. This is very simple question. See, I have a permanent magnet. This is north pole, this is south pole. Just kept an armature A, B, C, D, right? And here is a slip ring. Using commutator in DC generator, but in AC, we have two slip rings. This is S1 and this is S2 basically. There is a carbon brush, this is B1 and this is carbon brush B2 and this is a galvanometer. This is a galvanometer, right? See, this is north pole, this is south pole. That means magnetic field, this permanent magnet, north pole, south pole, this is a permanent magnet. Magnetic field is always from north to south. And this is generator. That means you have to move this coil and you will get electric current from it. So, just consider this is a shaft, right? Now, if I'm considering AB moving inside and CD outside, AB moving inside and CD outside, just like this, then you have to use a right hand rule, Fleming's right hand rule. What it is? This is showing the direction of magnetic field, thumb direction of force, and this one is induced current. Now, magnetic field I'm applying on AB, right? Magnetic field this way. Thumb representing inside, that means AB turns inside, that means middle fingers downward. That is, the direction of current is B to A. Now, coming here, S1, and due to this carbon brush B1, it's along this way. This is coming at B2, and this carbon brush connected to S2. Now this is moving here, D, and hence circuit completed. That means if I'm going to write the working, if AB inside and CD outside, then direction of current, direction of current is simple, B to A, then S1 B1, then in galvanometer it's a right hand side, then B to S2, and then D to C, hence circuit complete. Right. Now, if first half of the rotation completed, this AB moving inside and CD outside, now CD comes left hand side and AB moves right. This is the second condition. If first half of the rotation completed, then this will happen. See, this is armature, right? This is, sorry. This time this is S2, and this is B2 basically. This is S1 and here is B1 brush. There is no difference in connections, right? But what it is, see, this is north pole, south pole, magnetic fields moving north to south. Now this time, AB at right hand side, CD at left hand side, and in between this is a shaft. Right? Now applying same in the left hand side, I'm moving it in clockwise direction. Then what it is, this time CD moves in and AB outside. CD inside and AB outside, right? Then what? Just apply magnetic field in this way, Thumb represents, that means CD inside, then the direction of current is downward. Direction of current is in this way, downward. Now see, this is connected firstly in S2, then it's moving at B2, and this time the direction of current in this way. Now come at the B1, and B1 is connected to S1, which is in this way. That means CD inside, this time CD inside, AB outside, CD inside, AB outside, CD inside, AB outside. Then what? Direction of current. It is C to D, C to D, then S to B2, then B1 S1, then AB. Is it? Now, what you have to see, this is anti-clockwise and this is clockwise. That means if I am just using the formula EMF, that is E, which is equals to N d phi upon dt with negative sign. See what it is. If permanent magnetic field from north to south and a coil rotating inside the magnetic field, then in this position maximum number of field lines intersecting this coil. But when the coil is moving this way, the number of field lines crossing this cross section area is minimum, right? That means what? The output current is such like this is from 0 to maximum, then again moving to 0, then again in negative maxima, again 0. In this way, alternating current produced by a AC generator. Okay, see, this is the complete theory. Right? This is based on phi, which is equals to BA cos theta, BA cos omega t. Right? And then finally E equals to E naught sin omega t. You have to get this. This is E equals to E naught sin omega t. The maximum value is +1 and minimum value is -1. Right? This is omega t. This is omega t. And what about this? This is basically E naught. Peak value, peak EMF, is it? Okay, so what is full wave rectifier? Explain diode can be used to full wave rectifier. How diodes can be used? See, this full wave rectifier, that means which converts AC signal into DC signal. AC into DC, that is called rectifier. And how it is possible? See, I have a AC signal. See, this is the AC signal. Just use this is at input end, right? This is a transformer. Just put 2 diodes, right? And complete this. And using central trap transformer. Why using central trap transformer? See. When diode D1 is in forward bias, then D2 is in reverse bias. So that if you want to supply current in the circuit, then you have to complete the circuit. That's why here using central trap transformer. So that this is in forward bias, circuit completed. This is reverse bias, that means this is open. So that we are using central trap transformer. Diagram is okay. We have 2 diodes, right? Now see the working. See. In simplest way, see, if I'm considering just use color coding for the signals so that you can easily understand. If positive half of the AC current comes at the input end, that means what? This will turn at higher potential and this will turn at lower potential. Positive, that means what? This is at higher potential and this is at lower potential. This is at higher potential, this is at lower potential. Is it? If first half of the AC come at the input end, then this is at higher, this is at lower, this is at higher potential, this is at lower potential. In this time, diode D1 having the P-type material at higher potential and N-type at lower potential, so that diode D1 is in forward bias. For this time, diode D1 is forward bias. But here, this one is this p type of diode D2 is at lower potential, and the n type material it has higher potential, that is this is in reverse bias. See, I'm writing working here. Sorry, working here. For first half of the AC, what we'll get? See, just name it. This is A, B, C, D. Okay. E, F also. See. Now, A at higher potential and C at lower potential. So that D1 is in forward bias and D2 is in reverse bias. So that circuit complete A, B, E, F, A. A, B, E, F, A. And you will get, see, if this is input, then I'm just planning output here. This is input signal and this is for output signal. See, for this input, diode D1 conduct and you will get output at this load resistance. Okay. Now, for second half, I'm using green. For second half of the AC supply. See, for this, now this is at higher potential. This is at lower potential. Now, green color I am using for the second half. C is at higher potential, this is at lower potential. Now, this is at lower potential, this is at higher potential. This time, this is higher potential, this is at lower potential. That means D2 conducts this time. This is in forward bias, but here D1 is in reverse bias. So that can I written as A is at lower potential and C is at higher potential. So that D1 is in reverse bias and D2 is in forward bias. So that circuit complete. How circuit completed? See, this time C, D, E, F, C. C, D, E, F, C. Now, see, if circuit completed by C, D, E, F or circuit completed in such a way A, B, E, F, the direction of current through RL will be in same direction. So, C, D, E, F, C. Now, again, I have output, that is Y, D2. But the direction will be same for D1 and D2. That means this negative phase turn 180 degree shift, right? This negative phase shifted by 180, that means D1, D2. Again, you have this is due to D1 and again you have this is due to D2. This is full wave rectifier. This is working principle of full wave rectifier. Is there anyone having any problem? Just let me know. Right? See, this is the another way to show central trap transformer. This is another way to show central trap transformer. See, right? Okay, it's fine. Okay, it's fine. I hope you got the answer. Now, explain the formation of energy bands in solid using band theory. Differentiate between the conductors, semiconductors and insulator. This is again very simple question. As you know, conductors, semiconductors and insulators basically decided on the basis of energy band diagram. That is the band gap between this is valency band and this is conduction band, right? And this is called forbidden energy gap. Here potential barrier also, right? If the gap, the forbidden energy gap is too much, then it is insulator. Too much, that means there will be no chance to move valency electron in conduction band. so that no conduction occur. That's why it's called insulator. In semiconductor, if I'm giving some potential, valency band moving upward, conduction band moving downward, and there will be a possibility to jump the electrons from valency band to conduction band, and conduction occur after cutoff potential. That's why it's called semiconductor. But in conductor, it's partially overlapping. It's partially overlapping. See, this is conductor. This is conduction band, and this is valency band. But in semiconductor, valency band and this is conduction band. Energy gap, forbidden energy gap less than 3 electron volt. And if energy gap, forbidden energy gap is more than 3 electron volt, then valency band and conduction band are far away, so that no valency electron moves to conduction band to conduct electricity. Is it? Okay, it's fine. Okay, it's fine. Okay. Any issue? Just let me know in chat box. If is there any issue, let me know in chat box. Everything is going good? Just put a thumbs up. Put a thumbs up if you are alive. Guys, if everything is going good, then just put a thumbs up. Just put a thumbs up. Okay, it's fine. Okay, it's fine. Okay, it's fine. Now, you have option to download. The session PDF. You have option to download the session PDF from the description box, right? There will be a link. Just click and download the session PDF, and please share and subscribe the session. We'll meet in next session, and hopefully we will discuss more questions. Thank you so much for this session, and we'll meet in another session. Bye bye. Goodbye. Take care, everyone. Good night. Bye bye. Take care.